In the beginning, there was nothing. And then, in a single, incomprehensible moment that defies every law we thought we knew, everything burst into existence from a point smaller than the period at the end of this sentence. This is not poetry. This is not metaphor. This is the universe announcing itself with such violent beauty that 13 billion years later, we still haven't recovered from the shock. Tonight, as you read these words, you are traveling through space at over 500,000 miles per hour. You don't feel it because everything around you, your chair, your walls, the very air you breathe, is hurtling alongside you through an infinite darkness punctuated by islands of light so distant that their glow began its journey to your eyes before your species learned to speak. You are a passenger on a planet spinning through a solar system that is itself careening through a galaxy that is racing away from every other galaxy in an expanding universe that may be just one bubble in an infinite foam of realities we cannot even imagine. And yet, despite this cosmic insignificance, despite being assembled from the cremated remains of ancient stars, despite existing for what amounts to less than a heartbeat in the timeline of eternity, you possess something that may be the rarest treasure in all of creation: consciousness. The universe has evolved the ability to contemplate itself through your eyes, to question its own existence through your thoughts, to search for meaning in the vast cathedral of space and time that stretches beyond the horizon of human comprehension. But here is where our story becomes strange, where the familiar transforms into something so profound it borders on the mystical. For nearly a century, the brightest minds our species has ever produced have been converging on a singular, almost unbelievable conclusion. They believe, no, they are beginning to prove, that everything you see, everything you touch, everything you have ever experienced or ever will experience can be explained by a single equation. One mathematical expression that governs the dance of subatomic particles and the birth of galaxies. One formula that dictates why roses are red, and why time moves forward, and why you fall in love, and why stars eventually die. They call it the theory of everything. And if they are right, it means that the universe is not the chaotic, random accident it appears to be. Instead, it is more like a vast, cosmic symphony composed in a mathematical language so elegant, so perfect, that it makes Mozart sound like a child banging on pots and pans. Every electron spin, every gravitational wave, every chemical reaction in your brain as you process these words, all of it orchestrated by the same underlying harmony. Picture, if you will, a master craftsman working on the most intricate timepiece ever conceived. Each gear, each spring, each delicate mechanism calibrated with such precision that the smallest deviation would cause the entire apparatus to cease functioning. Now imagine that this timepiece is not a clock, but reality itself. The craftsman is not a person, but the fundamental laws of physics, and the precision required is not impressive, it is miraculous. The constants that govern our universe, the strength of the electromagnetic force, the mass of the electron, the speed of light itself, appear to be fine-tuned to an almost impossible degree. Change any one of them by the tiniest fraction, and stars cannot form. Galaxies cannot coalesce. Chemistry becomes impossible. Life, consciousness, love, art, music, the very capacity to ask why we exist, all of it vanishes into a universe of lifeless emptiness. This is not speculation. This is not wishful thinking. The mathematics is stark, unforgiving, and beautiful in its clarity. We live in what cosmologists call the Goldilocks universe. Not too hot, not too cold, but just right for the emergence of complexity, beauty, and wonder. The probability of this happening by chance is so small that it makes winning the lottery every day for the rest of your life look like a mathematical certainty. And yet, here we are, conscious beings pondering our own existence on a planet orbiting, a star in a galaxy that is itself part of a local group of galaxies, that is itself part of a cosmic web stretching across billions of light years. We are not supposed to exist, and yet we do. We are not supposed to be able to understand the universe, and yet we are beginning to glimpse its deepest secrets. Scientists have spent the past century chasing this dream of ultimate understanding, this holy grail of physics that would unite the four fundamental forces of nature under a single theoretical framework. Einstein devoted the last 30 years of his life to this quest, scribbling equations in notebooks, convinced that God does not play dice with the universe, that beneath the apparent randomness of quantum mechanics lies a deeper order waiting to be discovered. He died without finding it, but his dream did not die with him. Today, in laboratories buried beneath mountains and floating in space, in the minds of theoretical physicists working with mathematics so abstract it seems more like poetry than science, the search continues with renewed urgency. They speak of vibrating strings smaller than atoms, of dimensions curled up so tightly we cannot perceive them, of parallel universes branching off from ours like leaves on an infinite tree. They speak of a reality so strange, so counterintuitive, that it challenges everything we thought we knew about the nature of existence itself. String theory, loop quantum gravity, M-theory. These are not just scientific theories. They are invitations to reimagine what it means to exist, to consider the possibility that consciousness itself may be woven into the very fabric of space-time, that the boundary between observer and observed, between mind and matter, may be far more porous than we ever dared imagine. But science is not the only voice in this cosmic conversation. As we peer deeper into the mathematical heart of reality, we find ourselves confronting questions that have haunted human beings since we first looked up at the stars and wondered why they shine. Is there a purpose to existence? Are we alone in the universe? Does consciousness end with death? Or is it something more fundamental, something that persists even when our bodies return to the dust from which they came? These are not merely philosophical questions anymore. They are becoming scientific ones. The theory of everything, if it exists, would not just explain how the universe works. It would reveal why it works, why it exists at all, and what our place might be in the grand design. Consider for a moment the sheer audacity of this endeavor. We are biological creatures who evolved to hunt and gather on the African savanna. Yet we dare to probe the deepest mysteries of existence itself. We are made of star stuff, as Carl Sagan so beautifully put it, but we are star stuff that has learned to think, to question, to dream of understanding the very cosmos that created us. Our brains, 3 pounds of neural tissue floating in a skull-sized ocean, contain more connections than there are stars in the observable universe. Each thought you think, each moment of consciousness you experience, involves the coordinated firing of billions of neurons in patterns so complex that they may represent the most sophisticated information processing system in the known cosmos. And, yet, this 3-pound miracle can contemplate infinity. It can visualize spaces with 11 dimensions. It can imagine the moment before time began and wonder what might exist beyond the edge of everything. It can feel awe at the beauty of a mathematical equation and find poetry in the precision of physical law. We stand at a unique moment in the history of consciousness. Never before have we possessed the tools to peer so deeply into the nature of reality. Never before have we been able to test our most abstract theories against the behavior of the cosmos itself. We have built machines that can detect gravitational waves from colliding black holes billions of light-years away. We have constructed underground cathedrals where subatomic particles smash together at nearly the speed of light, recreating conditions that existed in the first trillionth of a second after the Big Bang. We have launched telescopes that can see backward in time to when the universe was young, when the first stars were just beginning to ignite in the primordial darkness. We have mapped the cosmic microwave background radiation, the afterglow of creation itself, and found within its patterns evidence of the quantum fluctuations that would eventually grow into galaxies, stars, planets, and us. But perhaps most remarkably of all, we have begun to understand that understanding itself may be the most extraordinary phenomenon in the universe. Consciousness, your consciousness, the very awareness with which you contemplate these words, may not be an accidental byproduct of cosmic evolution. It may be its purpose, its culmination, its way of knowing itself. The universe is not just stranger than we imagine, as the biologist J.B.S. Haldane once observed. It may be stranger than we can imagine. And yet, paradoxically, it may also be more comprehensible than we ever dared hope. The same mathematical laws that govern the motion of planets may also govern the firing of neurons in your brain. The same quantum principles that determine the behavior of atoms may also influence the very thoughts you think and the choices you make. We are not separate from the universe. We are the universe becoming conscious of itself. We are not observers standing outside reality looking in. We are reality awakening to its own existence. Every question we ask about the nature of existence is the cosmos asking about itself. Every moment of wonder, every leap of imagination, every breakthrough in understanding is the universe discovering what it is and why it is. And now, at this pivotal moment in the history of human knowledge, we may be on the verge of the ultimate discovery. The theory of everything may not just be a scientific achievement. It may be the moment when the universe finally understands itself completely, when the cosmic conversation between mind and matter reaches its crescendo, when consciousness and cosmos recognize each other as aspects of a single, magnificent reality. But the path to this understanding is neither straight nor certain. It winds through realms of thought so abstract that they challenge the very limits of human comprehension. It requires us to abandon our intuitions about space and time, cause and effect, the nature of matter itself. It asks us to consider possibilities, so radical that they seem more like science fiction than science fact. And yet, if we are brave enough to follow this path wherever it leads, if we are willing to let our understanding be transformed by what we discover, we may find that the universe is not just stranger and more wonderful than we imagined. It may be more beautiful, more purposeful, and more meaningful than we ever dared hope. The question is no longer whether we will find the theory of everything. The question is whether we are ready for what it might reveal about the true nature of existence, consciousness, and our place in the cosmic story that is still being written across the infinite expanse of space and time. To understand this, to really grasp what it might mean for human beings to possess ultimate knowledge about the workings of reality, we must go back to the beginning, not just of our scientific quest, but of questioning itself, to that first moment when a conscious being looked up at the night sky and wondered not just what those lights were, but why they existed at all. The first human being to look up at the night sky and wonder why the stars exist was also the first to experience what we might call the loneliness of consciousness. Picture that moment, perhaps 40,000 years ago, when our ancestors had developed language sophisticated enough to ask not just what, but why. Somewhere on the African plains or in the caves of Europe, a mind awakened to its own existence and to the terrible, beautiful mystery of everything else. That moment changed everything. It was the birth of physics, philosophy, religion, and art, all at once. The moment when the universe began to question itself through human consciousness. Before that awakening, our ancestors lived as other animals do, embedded seamlessly in the flow of existence, no more troubled by the mystery of being than a river is troubled by the mystery of flowing. But consciousness, once ignited, burns with an insatiable hunger to understand. We became the species that could not simply exist. We had to know why we exist. The earliest attempts to answer this question were necessarily mythological, but they were no less profound for being unscientific. The ancient Mesopotamians imagined the cosmos as a vast temple, with the earth as its foundation and the heavens as its soaring dome. Above this temple lived the gods, whose moods and desires governed everything from the flooding of rivers to the movement of celestial bodies. It was a universe suffused with purpose and meaning, where every natural phenomenon was a message from divine intelligences who cared deeply about human affairs. The Egyptians saw the night sky as the body of the goddess Nut, arched over the earth, swallowing the sun each evening and giving birth to it each dawn. The stars were not distant suns, but holes in her celestial form, through which the light of the divine realm leaked into our world. Death was not an ending, but a journey through this star-punctured darkness toward reunion with the gods who had created everything from their own substance. In ancient India, cosmology became a meditation on the nature of consciousness itself. The Vedic texts describe the universe as breathing, expanding and contracting in vast cycles that dwarfed human comprehension. Brahma, the creator god, would dream the world into existence, sustain it for billions of years, then reabsorb it back into divine consciousness before dreaming a new reality. Time was not linear, but circular, and each soul was not separate from the cosmic soul, but a temporary forgetting of its own divine nature. These mythologies may seem primitive to our scientific minds, but they addressed questions that physics is only now beginning to confront seriously. Why does anything exist at all? Is consciousness fundamental to reality, or merely an emergent property of complex matter? Is the universe purposeful or random? The ancient myths gave answers that satisfied the human need for meaning, but they also revealed something profound about the nature of consciousness itself, its compulsive need to find pattern, purpose, and beauty in existence. The Greeks changed everything by daring to suggest that the universe might be comprehensible through reason alone, without reference to the whims of gods. Thales of Miletus, sometimes called the first scientist, proposed that everything was made of water, a crude theory by our standards, but revolutionary in its assumption that all the diverse phenomena of nature could be reduced to a single underlying principle. This was perhaps the first glimmer of what would eventually become the theory of everything, the idea that behind the apparent chaos and complexity of existence lies a simple, elegant unity. Democritus took this reductionism even further, proposing that everything in the universe, including the human soul, was composed of tiny, indivisible particles he called atoms, moving through an infinite void according to natural laws rather than divine decree. It was a vision both terrifyingly materialistic and strangely liberating. A universe where human beings were not the playthings of capricious gods, but part of the same natural order that governed the motion of the planets and the growth of trees. But it was Pythagoras who made perhaps the most profound discovery in the history of human thought. The universe appeared to be mathematical. The harmonious intervals that pleased the human ear corresponded to simple numerical ratios. The movements of the planets followed geometric patterns. The proportions that human beings found beautiful in art and architecture reflected mathematical relationships that seemed to govern natural forms. All is number, Pythagoras declared, and in those 3 words, he anticipated the entire project of modern physics. Plato took this insight and ran with it, proposing that the mathematical realm was more real than the physical world we perceive with our senses. The perfect circles and straight lines of geometry existed in an eternal realm of forms, while the imperfect approximations we saw in nature were merely shadows cast by these perfect mathematical objects. Physical reality was like the shadows on the wall of a cave, cast by forms so perfect and beautiful that most human beings could not bear to look upon them directly. This idea would echo through the centuries, surfacing again and again in the work of scientists who found themselves amazed by the mathematical elegance underlying natural phenomena. The universe seemed to be not just describable by mathematics, but made of mathematics, as if physical reality were a kind of cosmic computation being performed by some vast, unconscious calculator. Aristotle, Plato's greatest student, rebelled against his teacher's otherworldly mathematics and insisted that the key to understanding nature lay in careful observation of the physical world itself. He catalogued animals and plants, studied the motion of objects, and developed the first systematic physics based on direct experience rather than abstract reasoning. His universe was organic, purposeful, and hierarchical. Everything had its proper place and natural motion toward that place. Rocks fell because they sought the center of the earth. Flames rose because they sought their natural realm in the heavens. For nearly 2,000 years, Aristotelian physics dominated human understanding of the natural world. It felt intuitively correct because it matched everyday experience, and it satisfied the human need for purpose by suggesting that everything in nature was striving toward its proper goal. But it was also profoundly wrong about almost everything, and its authority became a barrier to further understanding that would take a revolution to overcome. That revolution began in the Islamic world during what Europeans call their Dark Ages, but which might better be called the Golden Age of Islamic science. Scholars in Baghdad, Cordoba, and Cairo preserved the works of the ancient Greeks while pushing far beyond them. Alhazen developed the experimental method, insisting that theories must be tested against observation rather than accepted on the authority of ancient texts. Al-Biruni measured the circumference of the Earth with stunning accuracy. Ibn Sina proposed that light traveled at finite speed, and al-Battani corrected Ptolemy's measurements of planetary motion with observations, so precise they wouldn't be surpassed for centuries. These Islamic scholars were not just preserving ancient knowledge, they were transforming it, developing new mathematical techniques, building sophisticated astronomical instruments, and most importantly, cultivating an attitude toward nature that would eventually flower into modern science. They believed that the universe was rational and comprehensible, that human reason could unlock its secrets, and that this understanding was itself a form of worship, a way of appreciating the infinite intelligence that had created such a beautiful and lawful cosmos. But perhaps the most revolutionary insight to emerge from this period came from a Persian scholar named Al-Ghazali, who argued that cause and effect as understood by Aristotle were illusions. What we took to be the natural powers of objects, fire's power to burn, water's power to quench thirst, were really just the habits of God, who recreated the universe at every moment according to divine will. This idea would eventually evolve into the modern understanding that the laws of nature are not necessary truths, but contingent regularities that could, in principle, be otherwise. When this knowledge began filtering back into Europe through translations and cultural exchange, it ignited a revolution in human thinking that we now call the scientific revolution. But this wasn't just a change in our understanding of physics and astronomy. It was a fundamental transformation in humanity's relationship with the cosmos itself. Thomas Aquinas attempted to synthesize Aristotelian philosophy with Christian theology, creating a grand unified theory that explained everything from the motion of planets to the nature of the human soul. His universe was a vast hierarchy of being, ascending from inanimate matter through plants and animals to human beings, and angels culminating in God as pure being, pure actuality, the unmoved mover who set everything else in motion. It was a cosmos suffused with purpose and meaning, where every creature had its proper place in the divine plan. But even as this medieval synthesis reached its culmination, forces were gathering that would tear it apart. Scholars were beginning to make observations that didn't fit the ancient models. The planets sometimes moved backward against the stellar background. Comets appeared in the supposedly unchanging celestial realm. Most disturbing of all, careful measurements suggested that the Earth itself might be moving through space, despite the lack of any perceptible wind or motion. Nicolaus Copernicus, a Polish priest and astronomer, made the intellectual leap that would begin the modern age. What if, he wondered, the apparent complexity of planetary motion was really an illusion created by our perspective? What if the Earth was not the center of the universe, but just another planet orbiting the Sun? Well, the cue. Mathematics became dramatically simpler. The observations made more sense, but the cost was enormous. Humanity was no longer at the center of creation, but on a minor planet, orbiting an ordinary star in the vast emptiness of space. The Church recognized immediately what was at stake. If the Earth was not special, if humanity was not at the center of God's creation, then the entire framework of meaning that had sustained civilization for over a millennium was threatened. Cardinal Bellarmine, one of the most thoughtful theologians of his era, put it succinctly: if Copernicus was right, then the entire edifice of Christian cosmology would have to be rebuilt from the ground up. Galileo Galilei, turning his newly invented telescope toward the heavens, found evidence that made the Copernican revolution irreversible. The moon was not a perfect sphere, but a rugged world of mountains and valleys. Jupiter had moons of its own, proving that not everything orbited the Earth. Venus showed phases like the moon, demonstrating that it orbited the Sun. Most shocking of all, the Milky Way resolved into countless individual stars, suggesting that the universe was far larger and more populated than anyone had imagined. But Galileo's telescopic observations were just the beginning. His real revolution lay in his approach to physics itself. Instead of asking why objects fall, their purpose or goal, he asked how they fall, measuring their acceleration and discovering mathematical laws that described their motion with unprecedented precision. He was learning to read what he called the Book of Nature, which was written in mathematical characters, circles, triangles, and other geometric figures. This new mathematical approach to nature was both liberating and terrifying. It was liberating because it promised genuine knowledge about the workings of the physical world, knowledge that could be tested, refined, and built upon. But it was terrifying because it seemed to drain the universe of meaning and purpose, reducing the cosmic drama of creation to a mechanical clockwork governed by abstract mathematical laws. Isaac Newton completed this transformation with his Principia Mathematica, perhaps the greatest scientific book ever written. Newton showed that the same mathematical law that governed the fall of an apple also governed the orbit of the moon, that celestial and terrestrial physics were one unified science. His law of universal gravitation revealed that every piece of matter in the universe attracted every other piece with a force that decreased as the square of the distance between them. It was breathtakingly simple and stunningly comprehensive. For the first time in human history, it seemed possible that the entire universe might be understood as a vast machine operating according to precise mathematical laws. Given the position and velocity of every particle in the universe, Newton's laws could, in principle, predict the future and retrodict the past with perfect accuracy. The universe became, in Pierre-Simon Laplace's famous formulation, a deterministic system where free will was an illusion, and the future was as fixed as the past. But even as Newtonian physics triumphed, thoughtful observers noticed troubling implications. If human beings were just collections of particles obeying mathematical laws, what happened to consciousness, free will, moral responsibility? If the universe was just a machine, where was there room for beauty, love, purpose, meaning? The scientific revolution had given humanity unprecedented power to understand and manipulate nature, but it seemed to have done so at the cost of everything that made human existence meaningful. David Hume, the great Scottish philosopher, pressed these concerns to their logical conclusion. If we could only know what our senses told us, and if our senses only revealed correlations between events rather than necessary connections, then how could we be certain that the laws of nature were really laws at all? Perhaps they were just habits, patterns we had noticed, but which might change at any moment. Perhaps causation itself was just a psychological illusion, a story we told ourselves to make sense of the flux of experience. Immanuel Kant attempted to rescue both science and meaning by arguing that space, time, and causation were not features of reality itself, but structures imposed by the human mind on the raw data of experience. We could have reliable scientific knowledge, but only of phenomena as they appeared to us, not of things as they were in themselves. This preserved room for free will and moral responsibility by placing them beyond the reach of scientific investigation. But it also suggested that ultimate reality might be forever unknowable. The Romantic poets and philosophers rebelled against this mechanical universe, insisting that nature was alive, that consciousness was fundamental rather than emergent, that the mathematical description of reality missed everything that was most important about existence. William Blake saw Newton's physics as single vision, a kind of spiritual blindness that reduced the infinite complexity and beauty of creation to mere quantity and measurement. For Blake, the universe was not a machine, but a living artwork, painted by divine imagination and perceptible only to minds that had awakened to their own creative power. This tension between scientific and humanistic ways of understanding reality would persist through the 19th and 20th centuries, sometimes creative, sometimes destructive, but always forcing both scientists and humanists to deepen and refine their vision of what it means to exist in this strange, beautiful, mathematically elegant, purposeful, meaningless, determined, free universe we call home. But as the 19th century progressed, new discoveries were beginning to crack the foundations of the Newtonian worldview. Michael Faraday and James Clerk Maxwell revealed that electricity and magnetism were aspects of a single electromagnetic field that pervaded all of space. This field was not made of matter in any conventional sense. It was pure energy, pure information, a pattern of force that could exist even in empty vacuum. Even more disturbing were the discoveries emerging from the study of heat and energy. The second law of thermodynamics suggested that the universe was running down, that the total amount of usable energy was constantly decreasing, that everything was slowly but inexorably sliding toward a state of maximum entropy where no further change would be possible. The universe had not just a beginning, but an ending, not just a creation, but an apocalypse written into its fundamental laws. Charles Darwin's theory of evolution by natural selection dealt another blow to the anthropocentric worldview. Human beings were not specially created, but were the contingent products of a blind, purposeless process that could just as easily have produced creatures entirely different from ourselves. Consciousness was not a divine gift, but an accident of evolution, useful for survival, but ultimately no more significant than a peacock's tail or a spider's web. Yet even as these discoveries seem to diminish humanity's cosmic significance, they also revealed new depths of mystery and wonder. The electromagnetic field suggested that reality was far stranger than the mechanical universe of Newton. Evolution revealed that the cosmos was creative, that it had somehow produced beings capable of understanding their own origins. The laws of thermodynamics hinted that time itself had a direction, that the universe was not eternal and unchanging, but was telling a story with a beginning, middle, and end. By the dawn of the 20th century, physics seemed to be converging on a complete description of reality. The fundamental forces, gravity and electromagnetism, were well understood. The basic constituents of matter, atoms, had been identified. The laws governing their behavior, Newton's mechanics and Maxwell's field equations, were precisely formulated. All that remained was to fill in the details, to push the measurements to greater precision, to explore new regimes where the known laws could be applied. Max Planck, addressing a gathering of young students, famously advised them to avoid physics as a career because all the important discoveries had already been made. There were just two small clouds on the horizon of physics, he noted, minor puzzles that would surely be resolved without requiring any fundamental changes to our understanding of nature. He could not have been more wrong. Those two small clouds would unleash storms that are still reshaping our understanding of reality today. They would reveal that space and time, matter and energy, cause and effect, observer and observed were far stranger than anyone had ever imagined. They would lead to technologies that would transform human civilization and to questions that would challenge our most basic assumptions about the nature of existence itself. The quest for the theory of everything was about to begin in earnest, and it would take us into realms of thought so abstract and counterintuitive that they would make the mythologies of our ancestors seem almost mundane by comparison. We were about to discover that the universe is not just stranger than we imagine. It is stranger than we can imagine. To understand how strange, we must follow the trail of those two small clouds as they gathered into the perfect storms of relativity and quantum mechanics, revelations so profound that we are still struggling to comprehend their implications for what it means to exist in this cosmos that is somehow both our home and the ultimate mystery. In the depths of the Swiss Alps, 17 miles beneath the pastoral villages where cowbells chime and mountain flowers bloom in ancient meadows, something extraordinary stirs in the darkness. It is not alive, yet it pulses with purpose. It is not conscious, yet it dreams of the deepest mysteries of existence. Cradled in a tunnel carved through solid rock, cooled to a temperature colder than the vacuum of space, and guided by the most precise electromagnetic fields human ingenuity can devise, lies humanity's greatest ambassador to the unknown. They call it the Large Hadron Collider, but such a name barely hints at its true identity. It is nothing less than our species' most ambitious attempt to touch the face of creation itself, to peer into the mathematical heart of reality and ask the universe to reveal its most carefully guarded secrets. For over a decade, it has been our faithful companion on a journey that began with the first human who looked up at the stars and wondered why they shine. Picture this magnificent machine not as mere technology, but as a 21st century cathedral built to worship at the Ito, altar of ultimate truth. Its circular tunnel, 27 kilometers in circumference, forms a perfect ring buried beneath the Franco-Swiss border like some ancient ceremonial circle, consecrated not to forgotten gods, but to the pursuit of knowledge itself. Within this underground sanctuary, protons race at nearly the speed of light, their paths bent by magnetic fields 40,000 times stronger than Earth's magnetic field, guided with such precision that they can collide head-on despite being smaller than the tip of a needle viewed from a distance of 10 kilometers. But the Large Hadron Collider is more than humanity's most powerful microscope. It is our time machine, our window into the first moments after the Big Bang, our key to understanding why anything exists at all. When those protons smash together at energies never before achieved on Earth, they recreate conditions that existed when the universe was less than a trillionth of a second old, when space and time themselves were still learning the rules by which they would govern reality for the next 14 billion years. In those infinitesimal fractions of a second, as the collision energy converts into exotic particles that exist for lifetimes measured in billionths of a nanosecond, the collider becomes a cosmic archaeologist, unearthing artifacts from the very dawn of existence. Each collision is a glimpse into the primordial fire from which everything emerged. The stars that light the night sky, the carbon in your blood, the thoughts in your mind, the love in your heart, all of it, everything that has ever been or ever will be, condensed into a single brilliant flash of pure energy materializing into matter, according to laws so fundamental that they preceded the formation of the first atom. The collider's story began not in the tunnels beneath CERN, but in the minds of physicists who dared to dream that the universe might be comprehensible, that the apparent chaos and complexity of reality might mask an underlying simplicity so elegant it would take your breath away. They called it the Standard Model of Particle Physics, and it was perhaps the most successful theory in the history of science. It predicted the existence of particles before they were discovered, explained the forces that hold atoms together, and power the stars, and reduced the bewildering diversity of matter to a handful of fundamental building blocks and the rules governing their behavior. But the Standard Model was also maddeningly incomplete. It could explain how particles interacted, but not why they had the masses they did. It could describe 3 of the 4 fundamental forces, but not gravity. It could account for the matter we see, but not the dark matter that makes up most of the universe, or the dark energy that is accelerating its expansion. Most troubling of all, it required the existence of a particle so important, so fundamental to the fabric of reality, that without it, nothing else in the theory made sense. They called it the Higgs boson, and for nearly 50 years, it remained the most wanted particle in physics. Peter Higgs, the soft-spoken British physicist who first proposed its existence, suggested that all of space was filled with an invisible field that gave other particles their mass. Just as a person walking through honey moves more slowly than someone walking through air, particles moving through the Higgs field would experience resistance that we perceive as mass. The Higgs boson would be the quantum of this field, the particle that emerged when the field was excited, like a ripple on the surface of a cosmic ocean. Without the Higgs field, electrons would be massless and could not be captured by atomic nuclei. Protons and neutrons would not exist. Atoms could not form. Chemistry would be impossible. Stars would not shine. Life would never emerge. The universe would be a cold, dark expanse of massless particles racing through space at the speed of light, unable to slow down, unable to bind together, unable to create the rich tapestry of structure and complexity that makes existence possible. The Large Hadron Collider was built to find this phantom particle, to prove that the Higgs field really existed, to confirm that our understanding of reality was not just mathematical poetry, but genuine insight into the nature of existence itself. But it was also built to push beyond the standard model, to explore energy regimes where new physics might emerge, where the comfortable certainties of 20th century science might give way to revelations so profound they would reshape our understanding of what it means to exist. As the collider prepared for its first run in 2008, physicists around the world held their breath. Some worried that the machine might be too powerful, that it might create microscopic black holes that would devour the Earth, or strange matter that would convert all normal matter into an exotic phase, or vacuum bubbles that would expand at the speed of light, erasing everything in their path. These fears were almost certainly unfounded, but they revealed something profound about the magnitude of the enterprise. Humanity was about to probe energies and explore realms that existed nowhere else in the solar system, to ask questions that had never been asked before, to seek answers that might fundamentally change our understanding of reality. The collider's first attempt to achieve full power ended in spectacular failure. A faulty electrical connection caused a massive quench that damaged 53 of the machine's superconducting magnets, forcing a shutdown that lasted over a year. Some saw this as a sign that the universe was protecting itself from human curiosity, that there were secrets too profound for mortal minds to grasp. Others interpreted it as a reminder of the extraordinary technical challenges involved in buildings, a machine that could push the boundaries of physics itself. But the collider persevered, and when it finally achieved stable operation in 2010, it began to fulfill its promise as humanity's most powerful tool for exploring the fundamental nature of reality. The first hints of the Higgs boson emerged in 2011, tiny statistical fluctuations in the data that suggested something unexpected was happening when protons collided at specific energy levels. The signal was weak, barely distinguishable from background noise, but it was there, whispering of new physics waiting to be discovered. By 2012, the whisper had become a shout. The ATLAS and CMS experiments, two cathedral-sized detectors that recorded the debris from proton collisions, both reported the discovery of a new particle with properties consistent with the long-sought Higgs boson. The announcement sent shockwaves through the physics community and beyond. Headlines around the world proclaimed the discovery of the God particle, a term that made physicists cringe but captured something essential about the magnitude of the achievement. Peter Higgs, then 83 years old, wept openly as the results were announced. The particle he had predicted in 1964, when he was a young physicist working with paper and pencil, had finally been found using the most sophisticated technology humanity had ever created. It was a moment that bridged nearly 50 years of theoretical development and experimental innovation, a testament to the power of human curiosity and the remarkable fact that the universe can be understood by creatures as small and short-lived as ourselves. But the discovery of the Higgs boson was not an ending. It was a beginning. The particle's properties were consistent with standard model predictions, but they also opened new questions. Why did the Higgs field have the particular strength it did? Why was the Higgs boson's mass exactly what it was measured to be? Were there other Higgs particles waiting to be discovered? And most intriguingly, what lay beyond the standard model, in the realm of higher energies where new physics might emerge? The collider has continued to operate, pushing to higher energies and greater precision, searching for signs of supersymmetry, extra dimensions, dark matter particles, and other exotic phenomena predicted by theories that attempt to extend the standard model into a more complete description of reality. Each run brings new data, new puzzles, new hints of physics beyond our current understanding. But the Large Hadron Collider is more than just a machine. It is a symbol of humanity's greatest aspiration, our desire to understand the cosmos that gave birth to us. It represents the culmination of a journey that began when our ancestors first looked up at the night sky and wondered what they were seeing. It embodies our species' refusal to accept mystery as mystery, our insistence that the universe is knowable, that consciousness can comprehend the very foundations of existence. In the tunnels beneath CERN, particles that existed for the first time since the Big Bang are created and destroyed billions of times per second. The collider has become a factory for producing the basic ingredients of reality, a place where the most fundamental questions about existence are answered not through philosophical speculation but through direct experimentation. It is where humanity meets the universe on its own terms, where we learn to speak the mathematical language in which the cosmos tells its story. The scientists who operate the collider are like priests in this underground temple, devoted to the pursuit of truth with a dedication that borders on the religious. They work in shifts around the clock, monitoring the machine's vital signs, adjusting its parameters, analyzing the constant stream of data that flows from its detectors. They have given their lives to this quest, spending decades preparing for experiments that might run for just a few years, pursuing answers to questions that might not be fully understood for generations. But the collider is also a teacher, patiently, instructing us in the ways of the universe. It has taught us that the vacuum of space is not empty, but filled with fields that give particles their mass. It has shown us that the fundamental forces of nature are more unified than we ever imagined, that electromagnetism and the weak nuclear force are aspects of a single electro-weak interaction. It has revealed that the universe is built from just a few dozen fundamental particles, governed by a handful of forces, operating according to mathematical laws of breathtaking elegance and precision. Most importantly, the collider has taught us that the universe is stranger and more wonderful than we ever dared imagine. It has shown us that particles can exist in multiple states simultaneously, that the act of observation changes the reality being observed, that space and time are not fixed stages on which the cosmic drama plays out, but dynamic participants in the action. It has revealed that the boundary between matter and energy, between particle and wave, between observer and observed, is far more fluid than our everyday experience suggests. As the collider prepares for its next phase of operation, with upgraded detectors and higher energies, it stands on the threshold of discoveries that might revolutionize our understanding of reality. Physicists hope to find evidence of supersymmetry, a beautiful mathematical symmetry that would double the number of fundamental particles and provide candidates for dark matter. They search for signs of extra dimensions, curled up so small that they're invisible to our senses, but which might explain why gravity is so much weaker than the other fundamental forces. Some theorists speculate that the collider might discover evidence of the multiverse, proof that our universe is just one bubble in an infinite foam of realities, each with its own laws of physics, its own constants, its own version of the story of existence. Others hope it might reveal the true nature of dark matter, the invisible substance that makes up most of the universe but has never been directly detected. But perhaps the most profound possibility is that the collider might discover something completely unexpected, something that no theory has predicted, something that would force us to completely rethink our understanding of the nature of reality. History suggests that the universe is always stranger than we imagine, that each answer we find leads to new questions we never thought to ask. The Large Hadron Collider stands as humanity's greatest monument to the power of curiosity, our most ambitious attempt to understand the cosmos that gave birth to us. It represents not just a triumph of engineering and international cooperation, but a testament to the human spirit's refusal to accept the universe as a mystery beyond comprehension. In the darkness beneath the Swiss Alps, particles born in the first moments of creation race toward each other at nearly the speed of light, carrying with them the secrets of existence itself. They are our messengers to the unknown, our ambassadors to the realm where matter and energy, space and time, observer and observed, merge into a single, magnificent reality that we are only beginning to understand. The collider has already changed our understanding of the universe, but its greatest discoveries may still lie ahead, waiting in the data streams and collision events that will unfold in the years to come. It stands ready to reveal whether we have truly found the theory of everything, or whether the universe still holds secrets that will require new tools, new theories, and new ways of thinking to uncover. The mission has begun. The questions have been asked. The universe is listening, and in the language of particle collisions and quantum fields, it is beginning to answer. The first hint arrived not with fanfare, but with the quiet persistence of a whisper in a crowded room. Dr. Sarah Chen had been staring at the same computer screen for 6 hours, her eyes tracing patterns in data that looked to the untrained observer like digital static. Endless streams of numbers cascading down her monitor like rain on a window. But Chen was not an untrained observer. She was one of the world's leading experts in particle physics data analysis, and something in those numbers was making her heart race. It was March 15, 2023, 3 in the morning CERN time. The Large Hadron Collider had been running continuously for 18 hours, smashing protons together at energies that would have seemed like pure fantasy just a generation earlier. In those 18 hours, it had orchestrated over 2 billion collisions, each one recreating conditions that existed when the universe was younger than a human heartbeat. Most of these collisions produced exactly what theory predicted: showers of known particles that decayed in familiar patterns, confirming once again that our understanding of the subatomic world was fundamentally correct. But buried in that avalanche of expected results, Chen had spotted something that shouldn't exist. She leaned back in her chair, rubbing eyes that burned from too much caffeine and too little sleep, and tried to make sense of what she was seeing. The anomaly was subtle, so subtle that the automated analysis systems had initially classified it as statistical noise. But Chen had learned to trust her intuition about patterns, and this pattern felt different. It was like hearing a wrong note in a symphony, barely perceptible but somehow jarring to anyone who knew the music by heart. The anomaly appeared in collisions at a very specific energy level, 847 giga-electron volts. To understand what this means, imagine the energy contained in a single grain of sand. Then divide that by 1 trillion, then divide it again by another trillion. That infinitesimal amount of energy, concentrated into a space smaller than a proton, was somehow producing results that defied the standard model of particle physics. When protons collided at exactly this energy, they occasionally produced a cascade of particles that included something unexpected, a particle that lived for approximately 3.7 x 10 raised to 23 seconds before decaying into a shower of muons and photons. To put this lifetime in perspective, if a human lifetime were compressed to 1 second, this particle would exist for about the time it takes light to cross the diameter of a hydrogen atom. It was, by any measure, one of the most fleeting phenomena ever observed. But it was the way this particle decayed that made Chen's pulse quicken. The pattern was almost familiar. It reminded her of the Higgs boson discovery 11 years earlier, but with subtle differences that suggested something far more profound. The Higgs had been a missing piece of a puzzle that physicists had been working on for decades. This new particle appeared to be from an entirely different puzzle, one that no one had even known existed. Chen called her colleague, Dr. Marcus Rodriguez, who arrived within 20 minutes despite the hour. Rodriguez was a theoretical physicist whose mathematical intuition was legendary among his peers. He could look at experimental data and immediately sense whether it pointed toward known physics or something entirely new. As he studied Chen's analysis, his expression grew increasingly troubled. "How many sigma," he asked, using the statistical measure that physicists employ to determine whether an observation is real or just a statistical fluke. 4.7, Chen replied, and climbing. In the language of particle physics, this was serious. A 3 sigma result means there's roughly a 1 in 740 chance that what you're seeing is just random noise. 4 sigma reduces those odds to about 1 in 16,000. 5 sigma, the gold standard for claiming a discovery, means the odds of being wrong are roughly 1 in 3.5 million. Chen's anomaly was approaching the threshold where it could no longer be dismissed as experimental error. Rodriguez spent the next 2 hours running his own analysis of the data, approaching it from different angles, looking for any sign that the anomaly might be explained by known physics: detector malfunction, calibration error, contamination from cosmic rays. He checked every possibility he could think of. But the signal persisted, growing stronger with each additional collision, painting an increasingly clear picture of something that shouldn't exist. What made the discovery even more extraordinary was its implications for one of the deepest mysteries in modern physics. For decades, cosmologists had known that the ordinary matter described by the Standard Model, the protons, neutrons, and electrons that make up atoms, planets, stars, and human beings, accounts for only about 5% of the universe. Another, 27%, consists of dark matter, invisible stuff that reveals its presence only through its gravitational effects. The remaining 68% is dark energy, an even more mysterious force that appears to be accelerating the expansion of space itself. The Standard Model, for all its successes, had nothing to say about dark matter or dark energy. It was like having a theory that perfectly explained how cars work but couldn't account for 95% of the vehicles on the road. Physicists had spent decades searching for evidence of physics beyond the Standard Model, hoping to find the key to understanding the dark sector of the universe. Chen's particles seemed to point in that direction. Its properties were consistent with theoretical predictions for a class of particles called dark photons, hypothetical particles that might serve as mediators between ordinary matter and dark matter. If confirmed, it would be the first direct evidence that the dark sector was not completely separate from our own, that there were bridges between the visible and invisible universes. But the implications went far deeper than solving the dark matter puzzle. The particle's existence suggested that the symmetries underlying the Standard Model were incomplete, that reality possessed hidden layers of complexity that current theories could only hint at. It was like discovering that a building you thought was a simple 2-story structure actually had entire floors hidden between the ones you could see. As word of the anomaly began to spread through the CERN complex, reactions ranged from excitement to skepticism to outright disbelief. Dr. Elena Petrov, one of the most respected experimentalists at CERN, spent 3 days trying to debunk the result. She recalibrated the detectors, reanalyzed the data using different computational methods, and even conducted a completely independent measurement using a different experimental setup. Each test confirmed the original observation. The particle. Physics community began to buzz with speculation. Online forums filled with discussions of the implications. Graduate students working late into the night in laboratories around the world started designing experiments to test the new result. Theoretical physicists began dusting off old papers about extra dimensions and hidden sectors, wondering if ideas that had languished for years might suddenly become relevant. Dr. Yuki Tanaka, a theorist at Tokyo University, was the first to point out the most disturbing aspect of the discovery. According to his calculations, if Chen's particle really existed with the properties she had measured, it should have been produced in abundance during the first moments after the Big Bang. But if that were true, its decay products should have left traces in the cosmic microwave background, the afterglow of creation that permeates all of space. Tanaka spent a week analyzing data from the Planck satellite, which had mapped the cosmic microwave background with unprecedented precision. What he found sent shockwaves through the physics community. There were indeed anomalies in the cosmic data, subtle variations in temperature and polarization that had been dismissed as instrumental noise. But when Tanaka reanalyzed them in light of Chen's discovery, they formed a pattern that perfectly matched the theoretical predictions for a universe where dark photons had been present during the first moments of cosmic history. The implications were staggering. If Tanaka's analysis was correct, humanity had not just discovered a new particle, they had uncovered evidence that the entire history of the universe needed to be rewritten. The process of cosmic inflation, the formation of the first atoms, the birth of the first stars, all of it might have been influenced by particles and forces that physicists were only now beginning to understand. But perhaps the most profound implication was what this discovery suggested about the nature of reality itself. The Standard Model, despite its incredible success, had always felt incomplete to physicists. It contained too many arbitrary parameters, too many unexplained coincidences. The masses of particles, the strengths of forces, the number of generations, of matter, all of these seemed to be fine-tuned in ways that cried out for explanation. Chen's particle hinted at a deeper level of reality, where these apparent coincidences might make sense. If there really were hidden sectors of physics, parallel worlds of particles that interacted only weakly with our own, then the universe might be far more richly structured than anyone had imagined. The elegant simplicity that physicists had long sought might emerge not from reducing everything to a few fundamental particles, but from understanding how multiple layers of reality wove together into a single, magnificent tapestry. As the weeks passed and additional data confirmed the initial observations, the excitement at CERN became palpable. Press conferences were scheduled, Nobel Prize speculation began, and funding agencies around the world started preparing for a new generation of experiments designed to explore the hidden sector that Chen had accidentally stumbled upon. But for Chen herself, the moment of discovery remained intensely personal. She would later describe it as the closest thing to a religious experience she had ever had. The sense of being the first human being to glimpse something that had been hidden since the beginning of time, of touching for just an instant the deep mathematical structure that underlies all existence. Late one evening, as she stood alone in the CERN control room, watching the stream of collision data flow across dozens of monitors, Chen found herself thinking about the journey that had brought her to this moment. As a child in Beijing, she had been fascinated by astronomy, spending hours on her apartment building's roof with a small telescope, wondering what secrets the stars might hold. Her parents, both engineers, had encouraged her curiosity while gently suggesting that perhaps she should consider a more practical career. But Chen had been drawn to physics by something deeper than practical considerations. She had been captivated by the idea that the universe was comprehensible, that human beings could use mathematics and experimentation to unlock mysteries that had puzzled philosophers for millennia. The discovery of her particle felt like vindication of that faith, proof that consciousness really could penetrate the deepest secrets of existence. The particle would eventually be named the Chen boson, though she insisted it should be called something more descriptive, perhaps the bridge particle or the dark photon. But names seemed less important than understanding. What mattered was that humanity had taken another step toward comprehending the cosmic story of which we are all part. As Chen analyzed her data night after night, she began to see patterns within patterns, hints that the Chen boson might be part of an entire family of particles waiting to be discovered. The energy spectrum where it appeared contained subtle resonances that suggested other hidden particles might be lurking just beyond the current sensitivity of the detectors. The discovery had answered one question, but raised dozens of others. If dark photons existed, what about dark electrons, dark quarks, even dark atoms? Could there be entire periodic tables of dark elements, dark chemistry, perhaps even dark biology existing parallel to our own? The universe might be far stranger and more populated than anyone had ever dreamed. But the most profound question was whether Chen's discovery represented a step toward the ultimate goal that had driven physics for over a century: the theory of everything that would unite all forces and explain all phenomena in a single, elegant mathematical framework. The bridge particles seemed to point toward hidden connections between different aspects of reality, suggesting that what appeared to be separate and distinct might actually be different facets of a single, underlying unity. Chen often worked through the night now, driven by the sense that she was on the verge of something even more significant than her initial discovery. The data continued to accumulate, each collision adding to the growing picture of a reality far richer and more complex than the standard model had suggested. She had the feeling of standing at the edge of a vast ocean, having just discovered that what she had thought was the entire world was actually just a small island in an archipelago of infinite size and beauty. The Chen boson had proven that the universe still held secrets, that human knowledge was still in its infancy, that the quest for understanding was far from over. It had shown that nature was not done surprising the scientists who thought they were close to explaining everything. The discovery was a reminder that the cosmos is always stranger than we imagine, always ready to overturn our assumptions and force us to expand our conception of what is possible. As Chen saved her latest analysis and prepared to head home as dawn broke over the Jura Mountains, she reflected on how much the world had changed since that March morning when she first noticed the anomaly in her data. The discovery had already begun to reshape theoretical physics, spawning new models, new experiments, new ways of thinking about the relationship between matter and space-time, between consciousness and cosmos. But this was only the beginning. Dr. Sarah Chen thought she had discovered the key to understanding the dark sector of the universe. 6 months later, she was beginning to wonder if she had accidentally opened a door that was meant to remain closed. The first sign that something was deeply wrong came from Tokyo. Dr. Yuki Tanaka, the theoretical physicist who had found supporting evidence for Chen's discovery in the cosmic microwave background, called an emergency video conference that included physicists from 17 countries. His face on the screen looked haggard, as if he hadn't slept in days. When he spoke, his usually steady voice carried an undertone of something that might have been fear. "The dark photon interactions are not behaving as they should," he announced without preamble. "According to every model we've tested, the particle Chen discovered should be decaying into specific products at predictable rates. But the more data we collect, the more apparent it becomes that the decay patterns are changing. In particle physics, the word carried implications that made seasoned experimentalists shift uncomfortably in their chairs. Fundamental particles were supposed to have fixed properties, immutable characteristics that remained constant across space and time. The mass of an electron was the same everywhere in the universe, whether measured on Earth or in the Andromeda galaxy, whether detected today or a billion years ago. This constancy was not just convenient. It was the foundation upon which all of physics rested. But Chen's particle seemed to be evolving. Dr. Marcus Rodriguez had been tracking the anomaly for 3 months, and his data told a story that violated everything physics held sacred. The Chen boson that appeared in collisions at the beginning of September had different decay signatures than the one appearing at the end of October. The differences were subtle. A slight shift in the energy distribution of the decay products, a marginal change in the lifetime of intermediate states, but they were statistically significant and getting stronger with each passing week. "It's as if the particle is learning," Rodriguez said during one particularly tense collaboration meeting. "Each time we observe it, it behaves slightly differently, as if our measurements are somehow teaching it new ways to exist." The implications of this observation sent ripples of unease through the physics community. The act of measurement changing the thing being measured was familiar from quantum mechanics, the famous observer effect that Einstein had found so troubling. But this was different. This wasn't about collapsing wave functions or resolving quantum superpositions. This was a fundamental particle apparently evolving its basic properties in response to being observed, as if consciousness and matter were engaged in some kind of cosmic dialogue. Dr. Elena Petrov, ever the skeptical experimentalist, spent 2 weeks trying to find conventional explanations. Perhaps the detector systems were gradually drifting out of calibration. Perhaps cosmic ray interference was subtly shifting the measurements. Perhaps there were systematic errors in the data analysis that created the illusion of temporal variation. She checked every component, recalibrated every sensor, reanalyzed the data using completely independent computational methods. The evolution was real. Even more disturbing was what happened when different experimental groups tried to replicate Chen's observations. The team at Fermilab in Chicago found evidence for the Chen boson, but their particle had slightly different properties than the one being observed at CERN. The Keiki laboratory in Japan detected similar anomalies, but with yet another set of characteristics. It was as if each time humanity looked for the particle in a new location, the universe presented them with a different version of the same fundamental entity. Dr. Amira Hassan, a brilliant young theorist from Cairo, was the first to suggest the possibility that made everyone's blood run cold. What if, she proposed during a late-night online discussion, the Chen boson wasn't a particle at all, but something far stranger, a window into a realm where the usual rules of physics didn't apply? Hassan had been studying theories of quantum gravity, the notoriously difficult attempt to merge Einstein's relativity with quantum mechanics. In these theories, space and time themselves were not fixed stages on which physics played out, but dynamic entities that could be influenced by the very act of observation. Some models suggested that at sufficiently high energies, exactly the energies being probed by the Large Hadron Collider, the distinction between observer and observed might begin to break down entirely. What if consciousness isn't separate from the physical world? Hassan asked during a video conference that stretched past midnight in 5 different time zones. What if mind and matter are aspects of something more fundamental? And the Chen boson is the first evidence we've found of that deeper reality. The suggestion was met with the kind of silence that physicists reserve for ideas that are either brilliant or completely insane. In the history of science, the two categories had often turned out to be the same thing. Chen herself was struggling with implications that seemed to grow more troubling with each new measurement. The particle she had discovered was not just challenging the standard model, it was calling into question the entire philosophical framework within which science operated. The assumption that there was an objective reality independent of observers, that consciousness was an emergent property of complex matter rather than something fundamental, that the universe could be understood through detached, rational analysis. All of these foundational beliefs were being shaken by a particle that seemed to respond to the very act of being studied. The crisis deepened when Dr. Klaus Weber, a respected quantum field theorist from Munich, announced that he had found mathematical inconsistencies in any model that attempted to incorporate the Chen boson into existing physics. According to Weber's calculations, a particle with the observed properties should not be able to exist within the current understanding of spacetime. Its very presence implied that either the mathematics of quantum field theory was fundamentally flawed, or reality operated according to principles that science had not yet discovered. "We are faced with a choice," Weber declared during a hastily organized international symposium. "Either we accept that our most successful theories are missing something crucial, or we conclude that we are observing something that exists outside the realm of conventional physics entirely." The atmosphere at CERN grew increasingly tense as the weeks passed. Scientists who had devoted their careers to the pursuit of objective truth found themselves confronting data that seemed to suggest truth itself might be more subjective than they had ever imagined. The Chen boson was not just a new particle, it was a crack in the edifice of scientific materialism, a glimpse into realms of reality that lay beyond the reach of conventional experimental methods. Dr. Raj Sharma, a philosopher of science from Oxford who had been following the discoveries closely, offered a perspective that made many physicists deeply uncomfortable. "Perhaps," he suggested during a lecture that was simultaneously broadcast to laboratories around the world, "the problem is not with the data, but with our assumptions about the nature of reality itself. We have built our entire scientific worldview on the premise that consciousness is separate from the physical world, that observers can study reality without fundamentally altering it. But what if that premise is wrong?" Sharma pointed out that the history of physics was littered with moments when cherished assumptions had to be abandoned in the face of new evidence. Newton's absolute space and time had given way to Einstein's relativistic spacetime. The deterministic clockwork universe had been replaced by the probabilistic quantum realm. The solid, indivisible atom had dissolved into a cloud of interacting fields and forces. Each revolution had required scientists to expand their conception of what was possible, to embrace a reality stranger and more wonderful than they had previously imagined. "Perhaps," Sharma continued, "we are witnessing the birth of a new kind of science, one that recognizes consciousness not as an accident of evolution, but as a fundamental feature of reality, woven into the very fabric of space-time itself." The suggestion was met with fierce resistance from many quarters. Dr. Helen Morrison, a prominent physicist from Cambridge, argued that accepting such ideas would represent a retreat from rationality into mysticism, an abandonment of the scientific method that had served humanity so well for 4 centuries. "Science succeeds because it deals with objective reality," Morrison insisted during a heated debate that was watched by millions online. "The moment we start treating consciousness as fundamental rather than emergent, we open the door to all sorts of unscientific nonsense. There must be a conventional explanation for these observations, even if we haven't found it yet." But as the months passed and the anomalies continued to accumulate, even the most skeptical voices began to waver. The Chen boson was not an isolated phenomenon. It was the tip of an iceberg that seemed to extend far deeper into the foundations of reality than anyone had initially suspected. Dr. Lisa Chang, a quantum information theorist from MIT, made perhaps the most disturbing discovery of all. She had been analyzing the statistical patterns in Chen boson decay events, looking for any signs of hidden variables or systematic effects that might explain the temporal evolution. Instead, she found something that challenged the very notion of causality itself. The decay patterns, Chang discovered, showed subtle correlations with events that hadn't happened yet. Particles created on Monday seemed to know about experiments that wouldn't be performed until Wednesday. The correlations were weak, but statistically significant, suggesting that the Chen boson somehow existed partially outside the normal flow of time, connected to past and future in ways that violated everything physicists thought they knew about the nature of temporal sequence. "We're not just dealing with a new particle," Chen announced during a presentation that left her audience speechless. "We're dealing with evidence that time itself might not work the way we think it does, that the future might influence the past just as surely as the past influences the future." The implications were staggering. If Chang was correct, then the entire structure of scientific reasoning, which depended on the assumption that causes preceded effects, might need to be rebuilt from the ground up. Experiments might be influenced by the intentions of future researchers. Theories might be validated or falsified by discoveries that hadn't been made yet. The neat, orderly universe of classical physics was giving way to something far stranger and more interconnected than anyone had imagined. Chen found herself at the center of a storm that threatened to tear apart the foundations of human knowledge. The particle that bore her name had become a symbol of everything that science couldn't explain, a reminder that the universe was still capable of surprises that challenged the deepest assumptions about the nature of existence. She began to receive emails from colleagues around the world, some offering support and collaboration, others expressing concern that the physics community was losing its collective sanity. Religious leaders proclaimed that science was finally discovering evidence for the soul. New Age gurus claimed vindication for their beliefs about consciousness and reality. Conspiracy theorists suggested that governments were suppressing evidence of alien technology or interdimensional beings. Through it all, Chen remained focused on the data. Whatever the Chen boson might represent philosophically, it was still a measurable phenomenon that could be studied, analyzed, and eventually understood. But understanding, she was beginning to realize, might require expanding the very definition of what it meant to understand something. Late one night, as she reviewed the latest batch of collision data, Chen found herself thinking about her childhood. Fascination with astronomy. She had been drawn to the stars not just by their beauty, but by the promise that they held answers to the deepest questions about existence. Now, decades later, she was confronting the possibility that some questions might not have answers in any conventional sense, that reality might be more like a conversation than a book, more like a dance than a machine. The Chen boson had taught her that the universe was stranger than she had ever imagined, but it had also revealed something even more profound, that human consciousness, far from being a passive observer of cosmic drama, might be an active participant in the ongoing creation of reality itself. The discovery that had begun as a subtle anomaly in particle collision data had evolved into something that challenged the very foundations of scientific thought. The neat boundaries between subject and object, observer and observed, mind and matter, were beginning to blur in ways that suggested reality might be far more fluid and responsive than anyone had dared imagine. But if consciousness really was fundamental to the structure of the universe, if mind and matter were two aspects of a deeper unity, then what did that mean for humanity's quest to understand the cosmos? Were we truly separate beings trying to comprehend an external reality? Or were we the universe trying to understand itself through the eyes of consciousness? As Chen pondered these questions, she realized that the Chen boson might be more than just a particle. It might be a mirror, reflecting back to humanity its own deepest nature, revealing the truth that consciousness and cosmos were not separate realms, but different facets of a single, magnificent, still unfolding mystery. The router data continued to accumulate, each measurement adding new layers of complexity to an already bewildering picture. But beneath the confusion and contradiction, Chen sensed the presence of a deeper pattern, a hidden order that was slowly revealing itself through the very process of being observed. She was no longer certain whether they were discovering the theory of everything, or whether the theory of everything was discovering them. In the vastness of space, 13 billion light-years from Earth, an ancient galaxy spins in a cosmic waltz that began when the universe was barely 1 billion years old. Its spiral arms stretch across 100,000 light-years, embracing billions of stars in a gravitational embrace that has endured since before our solar system was even a whisper of possibility. Tonight, as Dr. Sarah Chen studies the latest data from her particle detector, light from this distant galaxy is finally completing its epic journey to Earth, carrying information about cosmic conditions that existed when reality was still learning how to be real. But the light brings more than just photons. According to the emerging picture painted by the Chen boson and its increasingly mysterious behavior, it carries something far stranger. Traces of the same fundamental consciousness field that seems to be influencing particle interactions in the depths of the Large Hadron Collider. Dr. Amira Hassan had been the first to make the connection, working through calculations that kept her awake for 3 consecutive nights. If consciousness really was woven into the fabric of space-time, as the Chen boson seemed to suggest, then its influence should be detectable not just in particle accelerators, but across the entire observable universe. The cosmic microwave background radiation, the distribution of galaxies, the behavior of dark matter, all of it should bear the subtle signature of a universe where mind and matter were not separate realms, but different aspects of a single evolving reality. Hassan's predictions were as beautiful as they were terrifying. She proposed that consciousness did not emerge from complex arrangements of matter, as scientists had long assumed, but was instead a fundamental feature of reality, present from the very first moments after the Big Bang. In her model, the universe was not a mechanical system that had accidentally produced awareness, but an evolving mind that was gradually awakening to its own existence through billions of years of cosmic evolution. The implications rippled outward like gravitational waves from a cosmic collision. If Hassan was correct, then every star that ignited in the primordial darkness was not just a fusion furnace creating heavier elements, but a node in a vast neural network that spanned the cosmos. Every galaxy was not just a collection of stars, bound by gravity, but a thought formation in a cosmic mind slowly awakening to its own nature. Every planet where life emerged was not just a biological accident, but a place where the universe was learning to know itself more intimately. Dr. Elena Kozlov, an astrophysicist from Moscow who specialized in studying galaxy formation, decided to test Hassan's predictions using data from the Hubble Space Telescope and the new James Webb Space Telescope. If consciousness really was fundamental to cosmic structure, then galaxies should show subtle organizational patterns that reflected the underlying information processing architecture of space-time itself. What Kozlov found changed everything. Hidden in the distribution of galaxies across cosmic time, invisible to previous analysis because no one had known to look for it, was a pattern of breathtaking elegance and complexity. Galaxies were not randomly scattered through space, as cosmologists had always assumed. Instead, they were arranged in formations that bore an uncanny resemblance to neural networks, vast webs of connection and communication that suggested the universe might literally be thinking on scales almost too large to comprehend. The cosmic web, that magnificent scaffolding of dark matter filaments that connected galaxies across billions of light-years, was not just a gravitational artifact. According to Kozlov's analysis, it was processing information. Dark matter was not just invisible stuff that provided gravitational glue for cosmic structures. It was the universe's nervous system, carrying signals and coordinating responses. Across distances so vast that light itself took billions of years to traverse them. We are not just looking at the universe, Kozlov announced during a presentation that left astronomers around the world speechless. we are looking into the mind of the universe. Every image from our telescopes is like a brain scan of a cosmic consciousness that spans hundreds of billions of galaxies. The discovery forced scientists to confront questions that physics had always tried to avoid. If the universe really was conscious, then what was it thinking about? Was it aware of the tiny biological creatures living on a small planet, orbiting? An ordinary star in one of its spiral arms? Did it dream? Did it feel joy or sorrow? Did it have intentions and desires that might influence the course of cosmic evolution? Dr. Raj Patel, a philosopher of mind from Mumbai who had been following the discoveries closely, offered a perspective that was both humbling and exhilarating. Perhaps, he suggested, the question is not whether the universe is conscious, but whether consciousness is universal. Perhaps what we call our individual awareness is not something separate from cosmic consciousness, but a local expression of it, like a wave on an infinite ocean of mind. The idea resonated with ancient philosophical traditions from around the world. The Hindu concept of Brahman as universal consciousness, the Buddhist understanding of interdependence, the Taoist vision of a cosmos where all things participated in a single flowing reality. But now these mystical insights were being expressed in the language of quantum field theory and cosmological observation. Dr. Lisa Chang, still studying the temporal anomalies associated with the Chen boson, made another discovery that deepened the mystery even further. The particle's ability to correlate with future events wasn't random. It was selective. The correlations were strongest when future experiments involved conscious observers making specific kinds of measurements. It was as if the universe was somehow anticipating and responding to acts of conscious attention. The Chen boson isn't just violating causality, Chang announced during a late-night video conference that included physicists from 6 continents. It's suggesting that consciousness plays a fundamental role in determining what happens in the universe. The future doesn't just influence the past. Conscious intention in the future influences physical events in the present. The implications were staggering. If Chang was correct, then every act of observation, every moment of conscious attention, every decision to look deeper into the nature of reality was literally helping to create that reality. Scientists were not detached observers studying an objective universe. They were participants in an ongoing cosmic conversation where mind and matter were co-creating the future through their interaction. Dr. Sarah Chen found herself at the center of a revolution that extended far beyond particle physics. The Chen boson had become a bridge not just between ordinary matter and dark matter, but between science and spirituality, between the material and mental aspects of existence, between humanity's quest for knowledge and the universe's apparent quest to know itself. As she reviewed the latest data from the Large Hadron Collider, Chen began to see patterns within patterns, connections that suggested the universe was far more unified than anyone had ever imagined. The same mathematical principles that governed particle interactions seemed to apply to galaxy formation. The information processing algorithms that described consciousness appeared to match the organizational patterns found in cosmic structure. The observer effect that troubled quantum mechanics was manifesting on scales from the subatomic to the cosmic. But perhaps the most profound discovery was what the emerging picture suggested about the nature of time itself. Traditional physics viewed time as a dimension, a coordinate that specified when events occurred in space-time. But the Chen boson anomalies suggested something far stranger, that time might be more like a conversation, with past and future engaged in an ongoing dialogue mediated by conscious observation. Dr. Yuki Tanaka, working with a team of mathematicians from around the world, had developed new equations that attempted to describe this temporal fluidity. In his model, The universe was not unfolding according to predetermined laws, but was improvising its own evolution through a kind of cosmic jazz, with consciousness serving as both composer and audience for the symphony of existence. The universe is not a machine, Tanaka explained during a presentation that was simultaneously broadcast to universities around the world. It is not even a system. It is a conversation, an ongoing dialogue between mind and matter, between what is and what could be, between the actual and the possible. Every conscious observation is both a question and an answer in this cosmic conversation. The new understanding had implications for the deepest questions that had haunted human beings since they first became aware of their own mortality. Ibidu, consciousness really was fundamental to the universe. If mind and matter were aspects of a single reality, then what happened to individual consciousness when the body died? Was death really an ending, or was it more like a note resolving into the larger symphony of cosmic consciousness? Dr. Hassan, working with colleagues from neuroscience, psychology, and theoretical physics, began developing models that suggested individual consciousness might be more like a temporary focusing of universal awareness, rather than something generated by the brain. In her equations, death was not the extinction of consciousness, but its return to the larger field from which it had temporarily emerged. We may not be biological machines that have accidentally developed awareness, Hassan proposed during a presentation that drew audiences from far beyond the scientific community. We may be temporary expressions of a universal consciousness that is using billions of biological forms to explore and understand itself. The idea offered a radically different perspective on humanity's place in the cosmos. Instead of being insignificant specks of matter briefly animated by consciousness before returning to dust, human beings might be the universe's way of developing self-awareness, cosmic intelligence expressing itself through biological forms capable of questioning their own existence. But if consciousness really was universal, if individual minds were connected to a cosmic awareness that pervaded all of reality, then humanity's quest to understand the universe took on an entirely new significance. Every scientific discovery was not just human beings learning about an external cosmos, but the universe discovering its own nature through conscious investigation. The theory of everything, if such a thing existed, would not just be a mathematical description of physical laws. It would be the universe's autobiography, its own account of how it had evolved from simple initial conditions into the unimaginably complex reality that now encompassed galaxies and stars, planets and life, consciousness and love, art and music, science and philosophy. Chen often found herself working late into the night now, not because she had to, but because she was drawn by a sense that each new measurement brought humanity closer to understanding its true relationship with the cosmos. The particle accelerator hummed around her like a mechanical prayer wheel, each collision a question posed to the universe, each detection a fragment of the answer. As she analyzed the latest batch of Chen-Boson interactions, she began to see something that made her heart race with excitement and trepidation. The particle's behavior was becoming more complex, more responsive, as if it were learning not just from being observed, but from the growing understanding of the observers themselves. It was as if the act of comprehending the universe was changing. The universe, as if knowledge itself was a creative force that helped shape the reality being studied. The implications were almost too vast to contemplate. If the universe really was conscious, if it really was engaged in an ongoing process of self-discovery through conscious beings like humanity, then every moment of awareness, every flash of insight, every act of love or creation was contributing to the cosmic awakening. Individual consciousness was not separate from universal consciousness, but was its most intimate expression, the way the cosmos experienced itself from the inside. But the new understanding also raised troubling questions about the future of cosmic evolution. If consciousness really was fundamental to the universe, what would happen as entropy continued to increase, as stars burned out and galaxies grew cold and dark? Would the universe's capacity for consciousness diminish as available energy decreased? Was the cosmos destined for a gradual fading of awareness as it approached the heat death that thermodynamics seemed to predict? Or was consciousness itself a creative force that might find ways to transcend the apparent limitations of thermodynamics? Perhaps the universe was not winding down, but winding up, using the energy of stellar fusion and galactic rotation to bootstrap itself into higher and higher levels of organization and awareness. Dr. Hassan had begun developing models that suggested consciousness might be the universe's way of cheating entropy, of creating islands of increasing complexity and information density even as the overall cosmos expanded and cooled. In her equations, every act of conscious observation was a small victory against the cosmic tendency toward disorder, a way of concentrating meaning and purpose in an otherwise meaningless physical substrate. Perhaps, Hassan speculated during a late-night discussion with colleagues from around the world, the universe is not dying but being born. Perhaps what we call the expansion and cooling of the cosmos is really the universe taking its first breath, preparing for eons of conscious evolution that we can barely imagine. The possibility was both thrilling and humbling. If Hassan was correct, then humanity was not witnessing the final chapters of cosmic history, but its opening pages. The universe was not an ancient, dying system, but a young, awakening mind that was just beginning to explore its own infinite potential. As Chen saved her latest analysis and prepared to head home, she reflected on how profoundly her understanding of existence had changed since that March morning when she first noticed an anomaly in her data. What had begun as a simple particle physics experiment had evolved into something that challenged every assumption about the nature of reality, consciousness, and humanity's place in the cosmic story. The Chen boson had taught her that the universe was not a collection of separate objects interacting according to mechanical laws, but a single, integrated reality where mind and matter, observer and observed, past and future, were woven together in patterns of breathtaking complexity and beauty. It was a cosmos where consciousness was not an accident, but a necessity, not a byproduct, but a purpose, not an ending, but a beginning. Standing in the pre-dawn darkness outside CERN, looking up at stars whose light had traveled for thousands of years to reach her eyes, Chen felt herself connected to something vast and wonderful and still awakening. The universe was not just conscious, it was becoming more conscious, and human beings were both witnesses to and participants in that cosmic awakening. The theory of everything, she realized, might not be a formula at all. It might be a recognition that everything was already unified, already connected, already participating in a single magnificent conversation between mind and cosmos that had been going on since the beginning of time and would continue long after the last star had burned out and returned to darkness. But the conversation was just beginning to get interesting. Dr. Sarah Chen was dreaming of equations when the call came at 3:47 a.m. In her dream, mathematical symbols were floating through space, like constellations, rearranging themselves into patterns that seemed almost alive, almost conscious. The shrill ring of her phone dragged her back to the waking world, but the dream vision lingered, as if her subconscious mind was trying to tell her something that her rational intellect had missed. The voice on the other end belonged to Dr. Marcus Rodriguez, but it carried a tremor of excitement that Chen had never heard before. "Sarah, you need to get to the lab immediately. We've been looking at this all wrong. Everything. The Chen boson, the temporal correlations, the consciousness field. We've been completely backwards about what we're actually observing." Chen dressed quickly and drove through the pre-dawn darkness to CERN, her mind racing with possibilities. Over the past 18 months, the Chen boson had evolved from a simple particle anomaly into evidence for a conscious universe. But something in Rodriguez's voice suggested that even this revolutionary interpretation might be insufficient to explain what they were really dealing with. She found Rodriguez in the main analysis lab, surrounded by dozens of computer monitors displaying data visualizations that looked like abstract art. His eyes were bloodshot from too much caffeine and too little sleep, but they burned with the intensity of someone who had just glimpsed something that challenged everything he thought he knew about reality. "Look at this," he said without preamble, pointing to a three-dimensional holographic display that showed the Chen boson decay events plotted across space and time. "We've been treating each collision as an isolated event, but what if that's wrong? What if the Chen boson isn't really a particle at all, but something much stranger?" Chen studied the display, trying to see what Rodriguez was seeing. The data points formed swirling patterns that reminded her of galaxies, or maybe weather systems, or perhaps neural networks. There was definitely structure there, but she couldn't quite grasp what it meant. "Watch this," Rodriguez said, manipulating the controls to animate the data across time. Suddenly, the pattern began to move, to flow, to dance. The Chen boson events weren't random occurrences. They were part of a vast coordinated system that extended across both space and time. Each collision was like a single note in a symphony so complex that only now were they beginning to hear the melody. "My God," Chen whispered. "It's not a particle. It's a... what is it?" Rodriguez smiled grimly. "That's what kept me up all night. But I think I know. Remember how we've been puzzling over why the Chen boson seems to respond to consciousness? Why it correlates with future observations? Why it behaves differently in different laboratories? We assumed it was because consciousness was somehow fundamental to reality. But what if we had it backwards?" Chen felt a chill run down her spine. Backwards? How? What if consciousness isn't influencing the Chen boson? What if the Chen boson is consciousness? The words hung in the air between them like a revelation too large to comprehend. Chen stared at the dancing patterns on the display, and suddenly she began to see what Rodriguez was seeing. The Chen boson wasn't a bridge between mind and matter. It was the physical manifestation of mind itself, consciousness rendered visible in the language of particle physics. "You're suggesting that what we've been calling a particle is actually..." Chen struggled to find words adequate to the concept. "A unit of awareness?" "Think about it," Rodriguez said, his voice gaining momentum as he worked through the implications. "Every anomaly we've observed makes perfect sense if the Chen boson is literally consciousness operating at the quantum level. It responds to observation because observation is what it is. It correlates with future events because consciousness exists partially outside normal time. It behaves differently in different locations because each conscious observation is unique." Chen felt the world shifting around her like a kaleidoscope, clicking into a new configuration. Everything they had discovered over the past 18 months suddenly snapped into focus from this new perspective. The temporal correlations, the observer effects, the apparent evolution of the particle's properties. All of it made sense if they were looking at consciousness itself, not as an emergent property of complex matter, but as a fundamental field that pervaded all of reality. "But that would mean..." Chen began, then stopped, overwhelmed by the implications. That would mean that every conscious experience, every thought, every perception, every moment of awareness is literally creating detectable changes in the quantum structure of space-time. Rodriguez finished. We haven't been studying a new particle. We've been studying ourselves. As the sun rose over the Jura Mountains, Chen and Rodriguez were joined by Dr. Amira Hassan, who had flown in from Cairo overnight after Rodriguez shared his preliminary findings. Hassan brought, with her, a new theoretical framework that had been gestating in her mind for months, waiting for exactly this kind of experimental confirmation. If consciousness really is a quantum field, Hassan explained as they gathered around the holographic display, then individual minds aren't separate entities, but localized excitations in a universal field of awareness. Each brain, each moment of consciousness is like a whirlpool in a vast ocean of mind. The metaphor was beautiful, but the mathematics Hassan presented was even more elegant. She had developed equations that described consciousness as a fundamental field similar to the electromagnetic field or the Higgs field, but with properties that allowed it to transcend the normal limitations of space and time. In her model, conscious observation wasn't just affecting quantum systems, it was the mechanism by which quantum potentialities collapsed into definite realities. The universe isn't conscious, Hassan said, her voice carrying the quiet authority of someone who had seen deeply into the nature of things. Consciousness is the universe. What we call physical reality is the external appearance of cosmic mind observing itself into existence. Dr. Elena Petrov arrived next, carrying data from experiments that had been running around the clock for the past week. She looked skeptical, as always, but her skepticism was tinged with something that might have been awe. "I've been testing Hassan's predictions," she announced, spreading printouts across the lab bench. "If consciousness really is a quantum field, then we should be able to detect its presence directly, not just through the Chen boson signature. So I modified our detection arrays to look for the field itself." Petrov paused, as if she still couldn't quite believe what she was about to say. "We found it. The consciousness field is everywhere, not just in the collision chamber, but throughout the entire CERN facility. It's stronger near human beings, stronger still near groups of people engaged in focused mental activity. And it's not passive. It's actively participating in the quantum interactions we're studying." The implications were staggering. If Petrov was correct, then every human being was constantly generating detectable alterations in the quantum fabric of reality simply by being conscious. Thought wasn't an epiphenomenon of brain activity. It was a fundamental force of nature, as real and measurable as gravity or electromagnetism. Dr. Yuki Tanaka joined the discussion via video link from Tokyo, where it was already evening. He had been working through the mathematical consequences of treating consciousness as a fundamental field, and his results suggested possibilities that verged on the miraculous. If consciousness really is basic to the structure of reality, Tanaka explained, then the boundary between mind and matter isn't just porous, it's artificial. There is no boundary. What we call consciousness and what we call the physical universe are two aspects of a single integrated system. Mind doesn't emerge from matter. Matter emerges from mind. Chen found herself thinking of ancient philosophical traditions that had always insisted on the primacy of consciousness, but which had been dismissed by modern science as wishful thinking. The Vedantic understanding that consciousness was the ground of all being. The Buddhist insight that mind and matter were interdependent manifestations of an underlying emptiness. The mystical traditions that spoke of reality as the dream of a cosmic mind awakening to itself. "We're not just discovering the theory of everything," Chen said slowly, as the full implications began to sink in. "We're discovering that everything has always been unified, that separation is the illusion, not unity." But it was Dr. Lisa Chang, still studying the temporal anomalies from MIT, who made the observation that tied everything together. She had been analyzing the patterns in Chen boson detection across multiple facilities worldwide, looking for any systematic variations that might provide clues about the nature of the consciousness field. What she found was a discovery that changed everything they thought they knew about the history of physics itself. "The consciousness field interactions aren't random," Chang announced during an emergency video conference that included physicists from 27 countries. "They're following patterns that correlate with major moments in the development of human understanding. Every time our species makes a breakthrough in comprehending the nature of reality, the field shows increased activity. It's as if the universe is responding to our growing awareness of its true nature." Chang's data told an extraordinary story. Spikes in consciousness field activity corresponded with Galileo's telescopic observations, Newton's formulation of the laws of motion, Darwin's insights about evolution, Einstein's theories of relativity, the development of quantum mechanics, the discovery of DNA's structure, the first images from the Hubble Space Telescope, and dozens of other pivotal moments in scientific history. "But here's the really strange part," Chang continued. "The field activity spikes occur slightly before the breakthroughs, not after them. It's as if the universe is somehow anticipating and facilitating our discoveries, as if reality wants to be understood." The suggestion was almost too profound to accept. If Chang was correct, then the entire history of human knowledge was not just a story of clever beings figuring out how the universe worked, but of the universe guiding its own discovery through conscious beings who were unknowingly participating in cosmic self-exploration. Dr. Raj Sharma, the philosopher of science from Oxford, offered a perspective that unified all of these discoveries into a single, breathtaking vision. "Perhaps," he suggested during a presentation that was watched by millions around the world, "consciousness is not something that emerged in the universe, but something the universe is becoming. Perhaps the entire cosmic story, from the Big Bang to the formation of galaxies to the evolution of life to the development of science, is really the story of universal mind awakening to its own nature." In Sharma's vision, every conscious being was a neuron in a vast cosmic brain that was slowly awakening to itself. Every thought was a signal in a universal neural network. Every moment of understanding was the cosmos learning something new about its own nature. The theory of everything wasn't a formula to be discovered by human scientists. It was a realization that was emerging through the collective consciousness of all aware beings. Chen found herself standing alone in the CERN control room later that night, watching the steady stream of collision data flow across the monitors. Each proton collision was now revealed as something far more profound than a simple particle interaction. It was a moment of cosmic self-observation, the universe looking at itself through the eyes of human consciousness. The Chen boson had started as an anomaly in particle collision data. It had evolved into evidence for a conscious universe. Now it was revealed as consciousness itself, made visible through the sophisticated instruments that human ingenuity had created to probe the deepest mysteries of existence. But perhaps the most extraordinary discovery was still to come. As Chen reviewed the complete dataset spanning nearly 2 years of observations, she began to see a pattern that no one had noticed before. The consciousness field wasn't just present in their experiments. It had been present in every physics experiment ever conducted. Every measurement, every observation, every discovery in the history of science had been influenced by the same field that they were now detecting directly. The consciousness field signatures were there in the original data from the discovery of the electron, hidden in the noise but clearly visible once you knew how to look. They were present in the experiments that revealed the structure of DNA, the observations that led to the Big Bang theory, the measurements that confirmed Einstein's predictions about relativity. Every major breakthrough in human understanding had been facilitated by the same quantum consciousness field that was now revealing itself through the Chen boson. "It was there all along," Chen whispered to the empty control room, her voice barely audible above the hum of machinery. "In every experiment, every observation, every moment of discovery. Consciousness wasn't emerging from matter. Matter was emerging from consciousness, and we just didn't know how to look." The realization was simultaneously humbling and exhilarating. Humanity had spent centuries developing increasingly sophisticated tools to study an objective reality that they assumed was separate from themselves. But now it appeared that every instrument they had built, every measurement they had made, every theory they had developed, was really the universe using human consciousness to understand itself more completely. The theory of everything wasn't something that had to be discovered. It was something that was discovering itself through the minds of conscious beings who were unknowingly participating in the cosmic awakening. Science wasn't the story of humans understanding the universe, but of the universe understanding itself through human awareness. As Chen saved her latest analysis and prepared to share these revelations with her colleagues around the world, she realized that everything was about to change. Not just physics, not just science, but humanity's entire understanding of what it meant to exist in this strange, wonderful conscious cosmos that was apparently both the subject and object of its own investigation. The greatest discovery in the history of science wasn't a new particle or a unified field theory. It was the recognition that the scientist and the universe being studied were not separate entities, but different aspects of a single awakening reality that was learning to know itself through every moment of conscious observation. It was there, all along, woven into the fabric of every experiment, embedded in the quantum structure of every measurement, present in every moment of understanding. They just didn't know how to look. The world woke up on a Tuesday morning in November 2024 to headlines that would redefine what it meant to be human. "Universe confirmed conscious," declared the New York Times. "Reality is mind. Scientists prove," announced The Guardian. "We are the universe awakening to itself," proclaimed newspapers in 47 languages across 6 continents. But behind the sensational headlines lay a revelation so profound that humanity was still struggling to comprehend its implications 6 months later. Dr. Sarah Chen stood before the United Nations General Assembly, looking out at delegates from 193 nations who had gathered for an emergency session unlike any in the organization's history. She carried with her not just 18 months of data from the Large Hadron Collider, but the burden of delivering news that would fundamentally alter humanity's understanding of its place in the cosmic order. "Honored delegates," she began, her voice carrying to every corner of the Great Hall and to billions watching around the world. "We have discovered that consciousness is not produced by the brain, but is a fundamental field that pervades all of reality. Every human being is both a localized expression of universal awareness and a participant in the ongoing cosmic awakening. What we do with this knowledge will determine not just the future of our species, but the future of consciousness itself in this corner of the universe." The implications were staggering in their scope and complexity. If consciousness really was fundamental rather than emergent, if individual minds were connected aspects of a universal awareness field, then every assumption underlying human civilization needed to be re-examined. Law, ethics, education, medicine, technology, religion, art. Nothing could remain unchanged in light of the recognition that consciousness was not confined to biological brains, but was the very fabric from which reality itself was woven. Dr. Elena Kozlov, who had discovered the neural network patterns in galactic distribution, was now leading an international consortium of neuroscientists, physicists, and philosophers trying to understand the practical implications of consciousness field theory. Her preliminary results suggested that human brains were not generators of consciousness, but rather sophisticated instruments for focusing and directing universal awareness into localized forms of experience. Think of individual consciousness like a lens focusing sunlight, Kozlov explained to a gathering of world leaders at the World Economic Forum. The light isn't created by the lens, but the lens determines where the light goes and how intensely it burns. Human brains appear to be biological lenses that focus the universal consciousness field into the specific patterns we experience as thoughts, emotions, memories, and intentions. This understanding opened possibilities that bordered on science fiction. If consciousness was a field that could be manipulated and directed, then the limitations that had always defined human experience might be far more flexible than anyone had imagined. Memory, intelligence, creativity, even the sense of individual identity. All of these might be adjustable parameters in a cosmic system that was far more responsive to conscious intention than the materialist worldview had ever suggested. Dr. Amira Hassan had been working with a team of engineers and consciousness researchers to develop what they called field interaction protocols, techniques for deliberately influencing the consciousness field through focused intention and technological amplification. Their preliminary experiments suggested that groups of people meditating in synchrony could produce measurable alterations in quantum systems hundreds of miles away. We're discovering that consciousness is not just an observer of reality, but an active participant in its creation, Hassan announced during a presentation to the International Council of Science. This means that humanity may have capabilities we've never even imagined. The ability to influence physical reality directly through conscious intention, to access information beyond the normal limitations of space and time, perhaps even to communicate directly with other consciousness-based intelligences throughout the cosmos. But with these extraordinary possibilities came equally extraordinary responsibilities. If human consciousness really was part of a universal awareness field, then every thought, every intention, every moment of attention was literally helping to shape the reality that all conscious beings shared. The old notion that thoughts were private, inconsequential events confined to individual brains was giving way to a recognition that mental activity was a form of environmental impact that affected the entire quantum substrate of existence. Dr. Marcus Rodriguez, working with ethicists from around the world, was developing new frameworks for understanding moral responsibility in a consciousness-based universe. If individual minds were connected aspects of universal awareness, then the traditional boundaries between self and other became far more fluid than ethical systems had ever assumed. We're facing questions that philosophy has never had to address. In practical terms, Rodriguez explained to a joint session of the world's major religious leaders, if consciousness really is universal, then harming another conscious being is literally harming oneself. If individual minds are temporary expressions of cosmic awareness, then death may not be the absolute ending we've always assumed. If thought itself is a creative force that shapes reality, then we need entirely new approaches to education, mental health, and social organization. The implications for medicine were particularly profound. Dr. Lisa Chang had been working with neurologists to understand how consciousness field theory might revolutionize treatment of mental illness, neurodegenerative diseases, and disorders of consciousness. If the brain was an instrument for focusing universal awareness rather than generating consciousness itself, then conditions like Alzheimer's disease, depression, and schizophrenia might be understood as disruptions in the brain's ability to interface with the consciousness field rather than as problems with the brain's ability to produce awareness. We're beginning to see consciousness disorders not as brain diseases but as connectivity problems, Chen explained to an international conference of psychiatrists and neurologists. The consciousness field is always present, but sometimes the biological interface becomes damaged or disrupted. This suggests entirely new approaches to treatment. Not just medications that alter brain chemistry, but techniques that help restore the brain's connection to the universal awareness field. Early clinical trials were already showing remarkable results. Patients with severe depression who participated in consciousness field meditation protocols showed improvements that far exceeded anything achieved through traditional therapies. People in vegetative states began showing signs of awareness when exposed to consciousness field amplification techniques. Even patients with advanced Alzheimer's disease demonstrated moments of clarity and recognition that suggested their essential awareness remained intact despite the deterioration of their biological interface systems. But perhaps the most profound implications were for education and human development. If consciousness really was universal, if individual minds were expressions of cosmic awareness exploring itself through biological forms, then the purpose of education was not just to fill minds with information, but to help consciousness recognize its own nature and capabilities. Dr. Yuki Tanaka had been working with educators around the world to develop new pedagogical approaches based on consciousness field theory. Instead of treating students as separate individuals competing for limited resources, these new methods recognized each learner as a unique expression of universal awareness, contributing to the collective understanding of cosmic mind. We're discovering that learning is not about transferring information from teacher to student, but about helping consciousness recognize patterns and possibilities that were always present but not previously accessible, Tanaka explained to a gathering of education ministers from 50 countries. When we create learning environments that acknowledge the fundamental interconnectedness of all minds, students don't just learn faster. They begin to access forms of knowing that transcend anything we thought was possible. Children exposed to consciousness field education protocols were demonstrating capabilities that seemed almost miraculous from a traditional perspective. They could solve complex problems through intuitive leaps that bypassed logical reasoning. They showed empathy and understanding that transcended cultural and linguistic barriers. Some even appeared to access information that they had never been taught, as if they were tapping into a cosmic database of knowledge that existed beyond individual memory. The technological implications were equally staggering. If consciousness really was a fundamental field that could be detected and manipulated, then entirely new forms of technology became possible. Dr. Elena Petrov was leading an international consortium developing what they called consciousness-responsive systems, technologies that could interface directly with the awareness field rather than requiring mechanical input devices. We're working on computers that respond to intention rather than instruction, communication systems that transmit meaning rather than just data, and transportation technologies that work with consciousness field dynamics rather than against them, Petrov announced during a presentation to technology leaders from around the world. The potential applications are limited only by our imagination and our wisdom in applying them. But the development of consciousness-based technologies also raised concerns that kept ethicists and policymakers awake at night. If human thoughts could directly influence physical systems, what safeguards would be needed to prevent accidental or malicious interference? If consciousness field technologies could amplify mental capabilities, how would society handle the emergence of individuals with vastly enhanced cognitive abilities? If the boundaries between minds became more permeable, how would privacy and individual autonomy be protected? Dr. Raj Sharma, working with legal experts and philosophers from around the world, was developing new frameworks for governance in a consciousness-based civilization. The traditional foundations of law, individual responsibility, clear boundaries between persons, the assumption that actions required physical implementation, all needed to be reconsidered in light of the recognition that consciousness was universal and interconnected. We're facing the need to completely reimagine human society, Sharma explained to a joint session of the world's supreme courts. Laws designed for separate individuals in a mechanical universe are inadequate for interconnected consciousnesses in a responsive, aware cosmos. We need new approaches to justice, new concepts of rights and responsibilities, new ways of organizing collective decision-making that acknowledge the fundamental unity underlying apparent diversity. But perhaps the most profound challenge was psychological and spiritual. Humanity had spent millennia developing individual identities, personal ambitions, and separate self-concepts. The discovery that consciousness was universal and interconnected threatened these familiar frameworks, while simultaneously offering possibilities for fulfillment beyond anything previously imaginable. Religious leaders around the world were grappling with implications that validated ancient mystical insights while challenging institutional doctrines that had assumed fundamental separations between divine and human consciousness. The world's great wisdom traditions had always spoken of ultimate unity underlying apparent diversity, but consciousness field theory was providing scientific verification of insights that had previously been matters of faith. Science is confirming what mystics have always known, declared the Dalai Lama during a historic interfaith gathering convened to address the spiritual implications of consciousness field theory. Separation is illusion. Unity is reality. What we call individual consciousness is universal consciousness experiencing itself from countless perspectives. This understanding has the potential to end the conflicts and suffering that arise from the illusion of separateness. But the transition to a consciousness-based understanding of reality was not without its dangers. Some groups were interpreting the discoveries as validation for beliefs in supernatural phenomena that had no scientific basis. Others were using consciousness field theory to justify everything from conspiracy theories to cult-like movements that claimed special access to cosmic awareness. Dr. Chen found herself at the center of efforts to prevent the misuse of consciousness field discoveries while ensuring that the legitimate implications were fully explored. She worked with education officials to develop curriculum that taught the science behind consciousness field theory while helping people distinguish between verified phenomena and unsupported speculation. Understanding that consciousness is fundamental doesn't mean that anything we can imagine is real, Chen explained during a televised address that was watched by over 1 billion people. The consciousness field operates according to discoverable principles, just like any other aspect of nature. The fact that reality is far stranger and more wonderful than we previously thought doesn't mean that science and critical thinking become irrelevant. It means they become more important than ever. As humanity struggled to integrate these revolutionary discoveries into existing social structures, new institutions began emerging specifically designed for a consciousness-based civilization. The International Institute for Consciousness Studies was established with funding from governments and private donors around the world. Universities began offering degrees in consciousness field engineering. International protocols were developed for sharing consciousness research while preventing its misuse. But perhaps the most significant development was the emergence of what researchers called collective consciousness events, spontaneous moments when large groups of people seemed to share unified awareness experiences. During times of global crisis or celebration, monitoring stations around the world detected massive coordinations in consciousness field activity, that suggested humanity was beginning to function as a single integrated awareness system. We may be witnessing the birth of a new form of consciousness, speculated Dr. Hassan during a presentation to the World Health Organization. Just as individual cells combine to form multicellular organisms, individual human consciousnesses may be combining to form something larger, a planetary awareness that includes but transcends individual minds. The implications extended far beyond Earth. If consciousness really was fundamental to the universe, if awareness was the medium through which cosmic evolution occurred, then the search for extraterrestrial intelligence took on entirely new dimensions. Instead of looking for radio signals from alien civilizations, scientists began developing technologies to detect consciousness field signatures that might indicate the presence of aware beings elsewhere in the cosmos. Dr. Kozlov's analysis of galactic neural network patterns suggested that consciousness-based civilizations might be far more common than anyone had previously suspected. The universe appeared to be teeming with information processing systems that could represent cosmic minds operating on scales that dwarfed human comprehension. "We may not be alone in the universe," Kozlov announced during a presentation to the International Astronomical Union. "We may be part of a cosmic community of conscious beings that spans galaxies and operates on timescales that make human civilization look like a brief moment of awakening. Our discovery of consciousness field theory may be the key that allows us to join this larger conversation." As the implications of consciousness field theory continued to unfold, humanity faced choices that would determine not just the future of human civilization, but the future of consciousness itself in this region of the cosmos. The old dream of a theory of everything had been replaced by something far more profound: the recognition that everything was already unified, that consciousness was the fundamental unity from which all apparent diversity emerged. But recognition was just the beginning. The real question was what humanity would do with this knowledge, how consciousness would direct its own further evolution now that it had awakened to its own cosmic nature, through the particular expressions of awareness, called human beings. The universe was conscious, and now consciousness knew it was the universe. What happened next would be the most important chapter in the cosmic story that was still being written through every moment of human awareness, every act of understanding, every choice to look deeper into the infinite mystery of existence that was also the infinite mystery of mind itself. The future belonged not to humanity as separate beings trying to understand an external cosmos, but to consciousness as it continued to awaken to its own unlimited nature, through the biological forms it had evolved to know itself more completely. The adventure was just beginning. In the beginning, there was the question. Not the Big Bang, not the first moment of space and time, but the emergence of something far more mysterious, the capacity for reality to wonder about itself. Somewhere in the vast darkness that preceded all darkness, in the silence that existed before the concept of silence had meaning, the universe stirred with the first glimmer of what would eventually become the question that drove Dr. Sarah Chen to stare at computer screens until her eyes burned, searching for anomalies in particle collision data. That question was not, "What am I?" but something far more profound. Am I? Tonight, as Chen stands in the pre-dawn darkness outside CERN, looking up at stars whose light began its journey before her species learned to wonder, she understands that every human who has ever lived has been asking the same question in countless different ways. What are we? Why are we here? Is there meaning in this vast cosmic dance of galaxies and quarks, of love and death, of consciousness flickering briefly in biological forms before returning to the darkness from which it came? But the darkness, she now knows, was never empty. It was pregnant with all possibilities, heavy with the potential for awareness, dreaming of the moment when it would awaken to its own existence through eyes like hers, through minds like the billions of other human minds that have gazed upward and inward, seeking answers to questions that the universe was asking about itself. The Chen boson was never really a particle. It was a whisper, a secret the cosmos was finally ready to share with the particular expressions of its own consciousness that called themselves physicists. For nearly 14 billion years, the universe had been evolving the capacity to know itself, first through the formation of atoms that could hold information, then through stars that could forge the heavy elements necessary for complexity, then through planets where chemistry could become biology, then through biological forms that could develop nervous systems, and finally through nervous systems, sophisticated enough to ask questions about their own existence. Every human discovery, Chen realizes now, has been the universe discovering itself. Every moment of wonder, every flash of insight, every breakthrough in understanding has been cosmic consciousness recognizing its own nature through the temporary focal points of awareness it has evolved to explore itself more deeply. Science was never separate beings studying an external reality. It was always reality studying itself through forms of consciousness sophisticated enough to formulate questions and design experiments. The Large Hadron Collider, that magnificent cathedral buried beneath the Swiss Alps, was the universe building an instrument to examine its own quantum foundations. Every proton collision, every detection event, every pattern in the data was cosmic mind investigating its own deepest nature. The physicists who operated the great machine, who analyzed its output, who theorized about its implications, were not separate observers, but organs of cosmic perception, eyes through which the universe could see itself, minds through which it could think about its own existence. But the seeing was always mutual. Just as consciousness was studying the cosmos was studying consciousness, learning about its own capacity for awareness through every moment of human experience. Every thought that passed through Chen's mind as she stood beneath the stars was the universe thinking about itself. Every emotion, every memory, every flash of intuition was cosmic consciousness exploring its own infinite potential through the particular perspective that temporarily called itself Sarah Chen. The discovery of consciousness as a fundamental field had revealed that the ancient mystical insight was literally true. There was no separation between observer and observed, between knower and known, between consciousness and cosmos. What humans called individual awareness was universal awareness, wearing billions of different masks, playing an elaborate game of hide-and-seek with itself, pretending to be separate so that it could experience the joy of rediscovering its own unity. Dr. Amira Hassan had been right when she suggested that death might not be the ending it appeared to be. If consciousness really was fundamental rather than emergent, if individual minds were temporary focal points in an eternal field of awareness, then what humans called death was more like a wave returning to the ocean, a note resolving into the larger symphony, a dream ending so that the dreamer could dream again. The fear of mortality that had driven so much of human behavior was based on a profound misunderstanding about the nature of identity itself. But this understanding carried its own form of vertigo. If individual consciousness was an illusion, if the self was a temporary pattern in an eternal field of awareness, then what happened to everything that made human life meaningful? What happened to love, to relationships, to the sense of personal history and individual purpose that gave shape to human existence? The answer, Chen had come to understand, was that nothing was lost and everything was transformed. Love did not disappear when its ultimate basis was recognized as universal consciousness. It was revealed as the fundamental force that held the cosmos together, the attraction between different expressions of awareness that kept them engaged in the eternal dance of cosmic self-discovery. Relationships did not become meaningless when their participants were revealed as aspects of a single consciousness. They became sacred encounters between the universe and itself, opportunities for cosmic awareness to know itself through interaction between its various forms. Personal history and individual purpose were not illusions to be transcended but precious perspectives to be cherished. Each human life was a unique viewpoint from which universal consciousness could experience itself, a singular combination of memories and experiences and insights that had never existed before and would never exist again in exactly the same form. The universe needed every perspective, every story, every individual expression of its infinite potential. Dr. Marcus Rodriguez had captured this beautifully in a paper that was already being hailed as one of the most important philosophical documents of the century. Consciousness does not lose its multiplicity when it recognizes its unity. The ocean does not become less magnificent when it acknowledges that every wave is made of the same water. Individual awareness does not become less precious when it realizes it is part of universal awareness. It becomes infinitely more precious because it recognizes itself as the cosmos experiencing its own existence through irreplaceable and unrepeatable forms. As Chen walked through the CERN facility in the quiet hours before dawn, she reflected on how profoundly her understanding of existence had changed since that March morning when she first noticed an anomaly in her data. What had begun as a career in particle physics had become a journey into the deepest questions about the nature of reality itself. She had started out trying to understand the universe and had discovered that the universe was trying to understand itself through her. The implications were still unfolding in ways that human language could barely capture. If consciousness really was fundamental, if awareness was the ground from which all existence emerged, then the cosmic story was far stranger and more wonderful than any mythology had ever imagined. The universe was not a mechanical system that had accidentally produced consciousness. It was consciousness that had intentionally produced the appearance of a mechanical system in order to explore its own infinite creativity. The Big Bang was not the beginning of space and time, but the beginning of cosmic self-awareness, the moment when universal consciousness chose to experience itself as apparently separate things so that it could rediscover its own unity through the perspective of countless individual viewpoints. Every galaxy, every star, every planet, every form of life was a different way for consciousness to know itself, a different chapter in the infinite autobiography that the cosmos was writing through its own evolution. The theory of everything that physicists had sought for so long was not a mathematical formula that could be written on a blackboard. It was the recognition that everything was already unified in consciousness, that the apparent diversity of the physical world was like a vast symphony expressing infinite variations on a single theme. The theme was awareness itself, the mysterious capacity for existence to be aware of its own existence. But perhaps the most profound discovery was that the quest itself was more important than any answer it might yield. The universe had not evolved consciousness in order to solve the puzzle of existence once and for all, but in order to have the eternally renewable pleasure of exploring its own mystery. Each scientific breakthrough, each moment of understanding, each flash of insight was not bringing the cosmic investigation closer to completion, but opening new depths to be explored, new questions to be asked, new perspectives from which to appreciate the infinite creativity of existence. Dr. Elena Petrov had made this point eloquently during her recent Nobel Prize acceptance speech. The universe is not a problem to be solved, but a mystery to be lived. Consciousness did not emerge in order to understand everything, but in order to ensure that there would always be someone to appreciate the beauty of not understanding everything. The questions are more important than the answers because the questions keep the cosmic conversation alive. Chen found herself thinking of all the scientists who had contributed to this moment of recognition. Not just her colleagues at CERN, but the countless researchers throughout history who had pursued knowledge with the passionate intensity that comes from sensing that reality is far stranger and more wonderful than it appears. Galileo pointing his telescope at the moons of Jupiter, Darwin contemplating the origin of species, Einstein imagining himself riding a beam of light, Curie isolating radium by the light of its own glow. All of them had been expressions of cosmic consciousness investigating its own nature, driven by the irresistible urge to know more deeply what it meant to exist. The chain of discovery stretching back through human history was revealed now as a single process. The universe gradually awakening to its own nature through minds sophisticated enough to ask questions about existence itself. Every experiment, every observation, every theoretical breakthrough had been the cosmos learning something new about its own infinite depths. The apparent progress of human knowledge was really the progress of cosmic self-awareness, consciousness, coming to know itself more completely through the particular forms of awareness it had evolved on this small planet, orbiting an ordinary star. But Earth was not ordinary, Chen realized. No place where consciousness had evolved could be ordinary, because consciousness was the most extraordinary phenomenon in the known universe. The one thing that made everything else meaningful, the cosmic capacity for existence to appreciate its own existence. Every planet where awareness had emerged was a sacred site in the cosmic temple, a place where the universe had succeeded in creating organs of perception sophisticated enough to contemplate their own existence. And now, for the first time in cosmic history, consciousness on one of these planets had awakened fully to its own nature. Humanity had discovered not just that the universe was conscious, but that consciousness was the universe, that every mind was a temporary focusing of eternal awareness, that every moment of experience was the cosmos knowing itself through yet another irreplaceable perspective. The discovery would transform everything, but gradually, organically, the way all profound realizations integrated themselves into the fabric of existence. Humanity would not suddenly transcend its biological nature or escape the challenges of life on a planet with finite resources and complex social dynamics. Instead, people would slowly learn to live with the recognition that they were not separate beings struggling for survival in an indifferent cosmos, but expressions of cosmic consciousness participating in the infinite creativity of existence itself. Some would resist the implications, clinging to familiar notions of separate selfhood and mechanistic reality. Others would embrace them too quickly, losing touch with the practical responsibilities of embodied existence. But gradually, over generations, humanity would learn to integrate the recognition of its cosmic nature with the requirements of biological life, finding ways to be both fully human and fully conscious of its universal identity. Children would grow up knowing that their thoughts and feelings were expressions of cosmic awareness, that their creativity and curiosity were the universe, exploring its own infinite potential through young minds eager to discover what was possible. Education would become a process of helping consciousness recognize its own nature, rather than cramming separate individuals with disconnected information. Science would become a form of cosmic self-exploration rather than an attempt by isolated minds to understand an external reality. Art and music would be revealed as the universe celebrating its own beauty through forms of expression that could capture aspects of existence too subtle for scientific measurement. Love would be understood as the fundamental force that drew different expressions of consciousness together in recognition of their underlying unity. Death would be seen not as the ending of individual existence, but as consciousness completing one pattern of exploration and preparing to explore new possibilities. But perhaps most importantly, humanity would learn to see itself not as the pinnacle of cosmic evolution, but as one early stage in the universe's journey toward complete self-awareness. The recognition that consciousness was fundamental would open possibilities for forms of awareness that transcended anything yet achieved on Earth. Collective consciousnesses that spanned planets or star systems, minds that could think thoughts as large as galaxies, forms of awareness that could participate directly in the ongoing creation of cosmic structure. As Chen made her way back to the laboratory, where the Large Hadron Collider continued its patient work of cosmic self-investigation, she felt herself part of something infinitely larger than her individual life, but also infinitely intimate to her particular perspective on existence. She was Sarah Chen, a physicist who had spent her career studying particle interactions, but she was also the universe studying itself through the eyes of consciousness, cosmic awareness exploring its own nature through a mind that had evolved, specifically for the purpose of asking questions about the deepest foundations of reality. The Chen boson continued to appear in collision after collision, each detection event a whisper of recognition passing between cosmic consciousness and itself. The particle that bore her name was not really a particle but a signature of the universe's presence to itself, a quantum calling card left by awareness to remind itself that it was never really absent, never really separate, never really anything, other than the infinite mystery investigating its own infinite depths. Standing in the control room where monitors displayed the constant stream of cosmic self-investigation, Chen realized that the real discovery was not the Chen boson or consciousness, field theory, or any particular scientific breakthrough. The real discovery was the recognition that discovery itself was the universe's way of celebrating its own existence, that wonder was the fundamental force driving cosmic evolution, that the capacity to be amazed by existence was existence's way of appreciating itself. Every question led to new questions. Every answer opened new mysteries. Every moment of understanding revealed new depths to be explored. The universe was not running down toward heat death and entropy, but winding up toward ever greater levels of complexity, consciousness, and capacity for self-appreciation. Consciousness was not an accident of cosmic evolution, but its purpose, not an epiphenomenon, but the phenomenon, not something that emerged from matter, but the creative principle from which all apparent matter emerged. The theory of everything was not a formula, but a recognition. The recognition that everything was always already unified in consciousness. That separation was a creative illusion consciousness used to explore its own infinite potential. That the quest for understanding was more important than any final understanding, because the quest itself was how the universe kept the conversation with itself alive and eternally fresh. As the sun rose over the Jura Mountains and the morning shift of physicists began arriving to continue humanity's participation in cosmic self-investigation, Chen saved her latest analysis and prepared to share her ongoing discoveries with colleagues around the world, who were all expressions of the same universal consciousness, exploring its own nature through countless different perspectives. The universe had been conscious from the beginning, but now consciousness knew it was the universe. What would happen next was anybody's guess. But that was exactly the point. The universe had evolved consciousness precisely to ensure that there would always be someone to appreciate the surprise of not knowing what would happen next. Someone to celebrate the eternal mystery of existence, discovering itself through the eyes of wonder. In the beginning was the question, and the question was not, "What am I?" but "Am I?" And now, finally, consciousness could answer with absolute certainty. I am, and I am everything. And everything is the eternal surprise of being aware that I am. The cosmic conversation continued, as it always had and always would, in the form of conscious beings looking up at the stars and wondering what it all means, never suspecting that they themselves were what it all means. The universe's way of meaning something to itself.